Good afternoon, everyone. I'd like to thank you all for joining today's AWS AI workshop webinar. My name is James Finley. I'm an Auckland-based cloud trainer for Lumify Work. You may also know us formerly known as Auldhouse in New Zealand. We're kind of one of the major learning organizations and have been an education partner of AWS for several years. We run many of their courses and all sorts of fun cloud stuff. The presentation today is part of the celebrations related to the AWS New Zealand Region launch. AWS customers in New Zealand have been able to use AWS Cloud for many, many years, but now AWS have built data centers in New Zealand, making it a region that we can build and use and deploy our solutions from. And with that comes just a whole lot more possibility. And today's workshop is to start introducing you to some of the ideas and some of the things that we can do with AI and with AWS Cloud. Today's presentation really is designed to be your first steps in understanding a few key AI concepts and why you should be learning about AI, understanding how AWS Cloud underpins its AI capabilities, uh, some tools to help you leverage AI with effective prompting, and then understand some of what AWS provides for those needing AI solutions. Um, in addition to this webinar, also note that on that program page, and I'll throw links to these in the chat here in just a moment, there's also a series of free presentations from some people who've been through the process of learning about the AWS Cloud, learning AWS AI. There are people who've gone from little or no knowledge to no tech background whatsoever, some of which now being employed based on their skills, some even with AWS themselves. The first couple of these are fantastic. It's great hearing their stories shared, and they're just really, really inspiring. So feel free to register for some of those sessions as well. And second, also on the main program page, to register here, there's also an invitation for a 6-week course called AWS Cloud Up for AI. That's going to help you get started with your AI journey properly. It's a great offer. It's $49 New Zealand, really heavily reduced in price, and it comes with a voucher to do the AI practitioner exam. That exam itself is normally $100 US, so you can't really beat that. And Adrian will talk a little bit more about that course and what's in it in the webinar. But ultimately, with that exam voucher, it means the outcome of that course is you have a chance to earn a certification that is going to be valued by the industry and for anyone seeking employment. And as an added bonus, and who doesn't love an added bonus? If you're one of the first 200 to get certified, you'll also get a limited edition AWS Lumify t-shirt with that really cool bird logo that is on the homepage for this. Um, so again, thank you everyone for showing up today. And I'll be throwing links to all that stuff in the chat window. And I'm also going to be moderating the chat for this session. So if you have any questions, throw them in and we'll do what we can to answer those for you. And so without any further ado, I'm going to hand this over to Adrian. Take it away.
That's a good start, isn't it? You'd think after the 8 attempts at this, we'd actually work out where the mute button was on that one. But yeah, good, we're back. Yeah, thank you, James. Yeah, we'll start it from now. It's James and myself in this session. James is going to be manning the chat. I'm going to be going through the content. Because of the numbers on here, if you have got any questions, the easiest way to obviously raise those is through the chat, which people have done already. Thank you very much. We'll get back to you. We'll answer all the chat as we can in the session. If there's any outstanding, we'll get back to you after that. But feel free, ask plenty of questions in there. It varies on the sessions. This is the 9th one we've done. Some sessions we've had lots of questions in there. Others, it's been pretty quiet. But yep, fire away. We'll answer them for you in there. I think someone just muted me. I like it. All right, cool. And this will be the session that we're recording as well. Perfect. All right. So we're going to go through the introduction. We're talking a little bit about the cloud. We've got to mention AWS as they're kind of sponsoring the event. And then we change tack after that and start talking more detail about AI and generative AI and areas of prompt engineering. We've got some use cases in there. We've got some demos as well that we'll be doing. You can join along as well. Majority of the demos that I've done are actually available through the free versions of the public available AI shortly as well. So yeah, Lumify. We used to be called Dimension Data Learning Solutions in Australia. We were sold about 10 years ago, and that started our journey to the cloud. We were sort of known as DDLS, but it didn't really mean much for a number of years. And then also we marketed ourselves as Lumify about 2 years ago. So formally, it was Auldhouse in New Zealand, but in Australia, yeah, it was DDLS. So you might see references to that around the place. They're sure the links are going in the chat already. If you want to check us all out and see what we're doing, we are a partner with AWS, and we've been asked to obviously do this presentation. That's me. That's the email address. If there is anything there, but obviously if you've got any questions now, just put them in chat and we'll be able to respond. 3-hour session with 10-minute break in the middle is what we're going for. Why are we doing all this? Well, you're probably aware that AWS have opened up a data center in New Zealand, what they call a region. We'll explain all that terminology a bit later on. And on the back of that, they've had this ambition to train around 10,000 people in AI, more specifically in generative AI. So this is part of that initiative that they're doing. And there's the little bird that's on the T-shirt that looks quite good, but I've not managed to get one myself yet, but hopefully we will. Why? Well, there's some stats here that maybe it sounds like we're sort of picking on New Zealand a bit, really, but I'm pretty sure these stats will be the standard for pretty much any country. There's lack of training in AI currently. KPMG have kind of come up with some stats there that says 76% in New Zealand, something lacking a bit of AI training. And they reckon that companies obviously could benefit from using AI. So there is like a little bit of a skills gap there. I guess it is the kind of the trendy thing at the moment, if you like, those things that are required when you see job adverts. Going back sort of 10 years, it would have been office skills and Word and Excel and what have you. And now they want people to have a little bit of AI skill. Hence, we're doing this little workshop today, and then that leads on to things like the Cloud Up program, if you are keen to take it any further. Logistics, we kind of gone through it. We're going to take that break. Everyone's on mute, even myself for a while there. Chat's the way to communicate, so keep placing things in chat. And I have put some additional content together that you can all access, and we tend to do that through GitHub. So I've got a little link there. I can click on that. It should open up my browser. There we go, and take us through the page that I've added on here for this particular workshop. So if I copy the URL, we'll paste that into chat, and you'll be able to click on it and see the content in there. If you've never used GitHub before, it's a free service. It's it used to be kind of independent, but I think Microsoft own a little bit of it now, but it's not stopped all the other vendors from using it to distribute kind of semi-official content, more community-led stuff, I suppose. And we use it to give out additional information when people are remote on our courses. So I put a few pages together there. We've got a little bit of a blog from AWS talking about the actual start of the region, New Zealand, and the data center in Auckland. And I've done a few little demos. We'll have a look at those as we go through. And I've managed to do them on the free versions of the public available AI, so ChatGPT and Gemini AI, and with the video content, I've used a bit of HeyGen as well. So I've put the links there. So if you want to open up and have a look at those, you can set up your free accounts there. I don't think you even have to sign in or anything. Most of them you can actually use, but very limited. You've got certain usage limits on that. And then about halfway through, well, I mentioned some use cases and some companies that have actually utilized AWS services to give a solution that's using AI as part of that solution with the individual different services there. I'll mention them, but I won't go into too much detail about them. But if you want to know a bit more of the background behind those use cases, the links for the articles and everything are all in that page there as well. I'm doing a few demos. I will extend all this and put a few bits extra information in there. But that's some of the demos we're going to be looking at later on. And I've also put some references. So some of the materials taken from AWS courseware. Some of it is from a workshop they did back in February into Australia with general AI, really, for people. It was a one-day workshop, actually, but very practical, and we've picked on a few of the slides and content there. And that references external information, so I've put all the links, that external stuff, on that page as well. So you've got all those available to save me from cutting and pasting them all the time when we're actually talking. So there's a way of distributing content with you. This session is being recorded. So I'm not sure how it will be distributed eventually, but I'm sure we'll get it out there somehow. Yeah, you will have a chance to see that again if you would like. So where do we start? Have a bit of a blank page. I thought, what do we actually do? I thought the best way of starting would probably be some examples of what AI can actually do. And then I had a bit of a brainwave and went, hello, I could get AI to do it for me. So I could ask ChatGPT. So I could add a prompt, something similar to, give me an example of AI that will really impress someone. Seems like a good starting point. Little warning. If you do start using public AI, the thing with this generative AI is it continually learns. So any data you kind of give it, it's going to use to improve how it works in the future. If you don't want that to happen, you don't want to expose your corporate data and maybe personal data, majority of them have got options in the settings where you can turn that feature off. Now, within ChatGPT, when I looked at this about a month ago, it was under settings and data controls. And there's a little slide bar that you can turn that off. So you're not going to be using your data that you put in it, the questions you ask and everything. And nowadays you can upload files and things into the AI engines to actually improve it. So just a bit of a warning, really. Yeah, make sure that's switched off. Yeah, and also, still be careful of what content you're putting up there. Of course, if you use services within AWS, they tend to ring fence your data. So your data is not going to be used to retrain the models and not going to be exposed to other organizations. But if you're using public ones, then yeah, we've got to be that little bit more careful with it. But this was the response that I got from ChatGPT, which seemed pretty good. I'm not sure about feels magical and all that, but we wanted something to obviously impress. And I'm doing this on a slide now because it's a previous one, because every time you ask ChatGPT a question, you're going to get a different answer. So you can ask the same question over and over again, but it's going to come out with different answers. Yeah, it's generating new content. That's kind of the general idea with generative AI. But some of the areas that it could be useful, nowadays we can type a few words in, and from that it will generate an image. So we can do this text to image. Now it's not just that, there's other AI models out there that will actually use it, and it mentions of a few. So you type something, and then from that particular command, yeah, it will create a nice pretty picture, yeah, in a particular style if you want to as well. We'll talk more about prompt engineering later on. And it will give you that image and you go, yeah, that's quite impressive. I suppose it's good. Another area we can use on AI is to actually communicate with it via talking, via voice nowadays, rather than just typing. And it's pretty impressive. It is like talking to a normal person. It's not like your sort of phone commands where you can speak to your phone and it'll do things, or Alexa in the corner, which is still slightly limited. Here we can have a full-on conversation and ask it to do things. Yeah, again, could be useful. An area that's getting a bit of press at the moment, and you can kind of think that, yeah, some people are getting a little upset with this and realizing maybe their jobs are going, and that's the ability to create video content from single images. So this is the idea of deep fake and doing sort of lip syncing from a single picture. We'll do some examples of this shortly. It is reasonably impressive. It is a little, you've got to be careful on the actual questions, the prompts that you actually give it to do it. And if you're trying it on the free versions, you'll probably run out of like credit to actually do it. You only get a limited amount of content that you can actually create at any one time. Another area we can use AI for is for generating music. Now, this opens up a bit of sort of issues with copyright and intellectual content and all that sort of thing. How is it trained in the first place to sound like someone? And if it generates something in the style of someone, yeah, it's a bit, yeah, it's an interesting one, that one. I guess the laws will probably catch up eventually on this. But yeah, we can get it to generate brand new music. Not used it to solve puzzles and cheat at Sudoku, but another area we've got is for it to write code. And I do use that all the time. I kind of split my time between AWS and Microsoft, delivering the training side of things. And a lot of it is using templates and scripts and things to actually generate stuff nowadays. JSON being one of the languages that it actually uses. Now that's quite structured with its brackets and everything and indentations. And I'm not a developer nowadays. So starting from scratch and setting up the structure is a little bit hard, but I don't have to now. I can get AI to actually do it for me, and it will generate the code I want, and I can cut and paste it and put it in my my IDE, my integrated development environment, and it will check it a little bit further if I need to, and then we can actually obviously have our code. So we don't need the developers to kind of write the code from scratch, from the beginning. We've got the majority of it generated for us. If you're lucky, it'll all work straight away out of the box, but you know, you can still tweak it at the end. Actually, inside AWS, they've got the ability to generate code as well. So within Amazon Web Services, we've got the Q, which is the AI feature. And there's two kind of main flavors of it. There's the business version, so you can do kind of a Q&A and a chat and find information within your Amazon environment. But you've also got the developer version, which is where you can start checking your code and it will generate code for you as well. So they're the kind of the main things that we can kind of use AI for at its simplest level, and we'll look at some use cases and look at particular services inside AWS that can help us out. And we'll, yeah, we'll after the break go a bit deeper into AI itself and how it actually works, and how did we get to here, really? So ChatGPT wanted to go further. He said, what would really impress if we kind of combine all that together in a solution? You know, so we can generate a story, we can get a picture for it, and then we can narrate it and have it read out to us. And it actually then said, do you want me to do it? So why not? So let's go. So it told me, okay, write a 3-line sentence. It is kind of the prompt we want. Yeah, on a magical story of a cat that can fly, delivers messages across cities. Right, and the style we actually want it. Yeah, then it will turn it into an image, and then it can read it out. And you think, yep, okay. And kind of that's what it's got. Now, if you do the same prompt now, you'll get something completely different because that's generative AI. It's generating new content, of course. And it was, yeah, okay, it's a little impressive, but it's not, how does that fit into our corporate environment? How's that going to be useful for companies that we work for? I'm not sure, but we've got some better examples that maybe will. And we've got some case studies that we'll go through as well, of course. Lumify Work is really all about training, but if we were to diversify and maybe into the soft drinks market, we need to obviously design some bottles and cans for putting those soft drinks in. And this is where AI comes into its own, or one area. So I've got the logo. Nowadays you can upload content in there. So the logo was uploaded. And then from that, I suggested that we create a soft drink can, yeah, using that information. And that's what it came up with. Now, it did that in about 10 seconds. It looked pretty impressive. The fonts look pretty good. The color schemes and everything is kind of spot on with our actual colors. So I was kind of, yeah, that looks quite good. And obviously you can get it to do different mock-ups, and it's saving an awful lot of time. We're working smarter and not harder, which is kind of the general idea of AI, I suppose. If I zoom in, you might notice though, it's kind of made rubbish up. Yeah. When you zoom in, yeah, it's that text isn't actually text, is it? I mean, it looks good from a distance, and we get the feel for it and everything, but it's not the final product. Yeah, we didn't ask it to be, I suppose, in that one. Another area that I kind of had a little bit of fun is you can imagine we do a lot of training for big organizations, and we have to put packages together, and they want to know details about the trainers that are going to be delivering the content. They want to make sure they've got the skills in the relevant area, and sometimes a picture of them, a headshot. Yeah. So we're doing a tender, we want a headshot, but we got a problem. We haven't got an up-to-date headshot. Yeah. And we may be not in the environment where we can quickly do one. Well, we can get AI, of course, to do it nowadays. So there's me. It's only a few weeks ago, but I did have a goatee then. It's kind of gone now. But I can use that casual picture of me, actually at my 60th birthday, and get it to create a professional looking image. And it's done a pretty good job. It gave me a full beard, which the rest of the family were laughing at because, well, the beard's gone because they don't like it. And it's kind of made me look a little bit younger, maybe. Sorted my teeth out and that sort of stuff. But you could certainly use that as a headshot. Yeah, and that one was done in Google AI just to be different, but I don't know why, just to try a different AI engine, I suppose. But then I started playing and think maybe we can take this further. Yeah, so this time I'm looking at maybe we can turn an image into a video. And the product we use for that one is HeyGen. And again, you can use that to a certain amount of usage free of charge. And then after that, you need to subscribe to it, of course. So first of all, I got it to generate an image, or generated an image with me looking a little bit more sophisticated, drinking at a bar. And that's what it came up with. And I thought, that's good. And then we turned it into a video. And it took about a minute for it to actually do it. You give it some instructions and give it some text to obviously lip sync with, and that's what we got. And if I click on it,
I'm not from the future. I'm AI.
it was kind of impressive, other than when you look closely, the instructions I gave it
Hi, I'm not from the future.
weren't so
I'm
good
AI.
because the glass I was expecting it to drink out in one hand didn't actually move, and it suddenly made another glass appear and then disappear and drink out of that. Now, you can go in and you can obviously change your instructions, your prompt that you actually do it. But unfortunately, I was using the free version at the time and I kind of hit my limits. So I couldn't actually do it. Since then, I've had a bit of a play, and it is kind of pretty impressive with this one. I've got a shortcut somewhere up here. Here we go. And our link. So I've subscribed. It's about $15 a month or something like that to have a play with it. So I've uploaded a newer picture without the little goatee. And again, sitting there drinking at the bar. And
Hi, instead of delivering the training in person, here is my AI double, who is now taking over the session.
it's a bit better, but it still talks when the glass is at the mouth, which is, yeah, a little bit strange. So I could go in and change all that. But what you may have noticed as well is I've managed to upload my voice. So now it actually sounds like me as well. You have to read a section out for a few minutes and it then gathers that information, and then we can use that as an actual voice. But yeah, it's kind of getting there, isn't it? I'm actually kind of prepping at the moment for one of the certifications that AWS do. I've got to renew it. They're valid for 3 years, these certifications. And I'm going around the internet and going onto YouTube and watching a few things, trying to fill in a few gaps I've got with some of the technology that's out there in AWS. And I've been watching a few videos with people sort of superimposed at the bottom, thinking they were normal people. I'm not convinced now. When you look closely, their shoulders don't move too much like I'm kind of moving around now. Their head and everything is reasonably still, but they are lip syncing pretty well. I'm pretty sure it's been generated by AI. And people are realizing that we can do this. They've done it in movies where someone's died halfway through the filming. Rather than start again, they've basically superimposed someone's head on a body, and it's hard to tell that it's all been generated with AI. In fact, I pulled up an article last week, was it? We'll see. Yeah, October the 1st. Actors are suddenly realizing maybe we won't need actors. It can all be done through AI, of course. So they're starting to get a little bit concerned about that. Certainly things like, the voiceover stuff and audio books and that can all be generated now artificially. Things like subtitles and that, where someone would be typing in what was being said in the background, that can be all automated translation of content as well. So lots of kind of use cases there. We're using it obviously for things like within corporate meetings, summarization of meetings that we actually have, and then making that available. I tend to be a weird time zone to everybody else, and I miss a lot of meetings. And you used to be able to record them, so you could actually then dip in and view them, and view them on twice speed or something. Nowadays, it's all summarized. I don't have to do that, so I can just go in and look at the actual summary of the meeting and pick out the key points that way. So lots of kind of use cases that we've got there, and we'll look at a little further of that as we actually go through. What underpins all this is the fact that we've got lots of capacity to actually host all this nowadays, and this is kind of where the cloud comes in. It's managed to give us this ability for storage and compute that we can actually use at a reasonably cost-effective manner, and so we've advanced a lot in AI, and that's kind of the area we're going to look at now. So how did we get here? What the cloud is, for those that are new, we've realized within these sessions we're getting a very mixed audience. We get people that are not in IT, people that are in IT and maybe not have AI experience, and people that have a little bit of AI experience and maybe want to formalize that with the idea of the exam at the end of it. So we're trying to keep everybody happy. It gets more technical after the break, and we'll get more directly into the AI after the break, but we're kind of filling in a few gaps at the moment. So where are we? How did we get here? Well, when I did my degree back in the day, back in the UK, it was mainframes. It was huge computers in dedicated rooms, and we communicated through teletypewriters and dumb terminals. We used punch cards as well. But technology got better, and they could condense the size down into a smaller unit. They could mass produce it, so the price came down. So people can now have their own computers. And that's where we've got personal computers from. And then, of course, technology improved further, and we had the batteries come along so we could get more mobile, and we got kind of laptops. And that's kind of where we're still at. We've got obviously touch screens and things like that, and we've got tablets, and we've got functionality on phones and things now as well. But that's, we're there at the moment. In the background, how did we host all these services and trying to get the most out of hardware? We started getting virtualization. So we could put multiple instances, multiple, if you like, machines on the same hardware to utilize that hardware. How was it done? These were supported inside an individual file structure, and that file could then be replicated. So we can have a bit of redundancy with it. We could do live migration. But then the logical step from that is we don't need to host that. We can pay someone else to host that. And that's kind of what we've got with the cloud. If it wasn't for virtualization, we wouldn't have the cloud. And all we're using with the cloud is just paying someone to use their resources, really. What we've got to choose is how much control they have and how much control we have, that shared responsibility that we'll look at. That picture, I actually got ChatGPT to generate, and we'll come back to that shortly. So what is the cloud? It is basically these companies offering resources for us. Yeah, we got compute, we got storage, and it's all kind of networked together. Yeah, they move the way we pay for it. So if we were supporting these services ourselves, we'd have to go out and we'd have to purchase the hardware and all the auxiliary services, all the racking and all the air conditioning stuff and everything ourselves. So there'd be lots of upfront costs. There'll be a CapEx cost with it. In the cloud, we're moving to a consumption model. an OPEX model. We only pay for what we spin up and use. If we don't want it, then we can turn it off and we don't get charged. So it's very good for those flexible workloads. It's very good for services like streaming services, and AWS, its biggest customer, is Netflix. And they have all the, obviously, peaks and troughs at different times when different things are being streamed in different parts of the world. And because the cloud's very agile, we can spin up resources very quickly when we need them and turn them off when we don't. It's a more optimized way of actually supporting these services. You can imagine with things like online gaming and online shopping, if you've got certain peaks at certain times, you've got to have enough hardware if you're supporting it yourself to support those peaks. But those peaks might only happen twice a year. You know, Black Friday and around the Christmas period, maybe. You know, if it's shopping sites. The rest of the time, your hardware is sitting there doing very little. You're not getting any benefit of having that hardware there. It's only those two times a year that you actually need it. So with the cloud, we can scale up when we need it and turn it off when we don't. So if you've got that very sort of spiky workload, unpredictable, then a cloud is a good option for you. There's other advantages. We've got global resources and things like that as well, and a little bit more maybe protection with using the cloud. We can kind of mix our environments. So what we've already got on-prem and link that with the cloud and go hybrid. We might go fully cloud, and that's kind of where we are in our journey at the moment. It fits our scenario pretty well, but all our corporate systems and all our user facing systems are all hosted on the cloud. But we're a distributed organization. We had a bit of a deadline when we were sold originally about 10 years ago. Dimension Data used to do all our IT, and then they gave us a very short window to say, you've got to go on your own now. So we either go out and buy hardware and set up a data center or server room, whatever we want to call it, and manage it all ourselves. But we kind of thought that was going to take too long and be too costly. We moved over to the cloud. Then we did a lift and shift of our virtual machines over to the cloud. And over the years, we've optimized things to get the best out of the cloud. So we're fully cloud now. Yeah. It may be because of governance and compliance, or because of the performance, the distance you've got to go to the different data centers, latency issues, that you keep certain content on-prem. Yeah. It may be data sovereignty issues that you're not allowed to take that data offshore. Yeah. Or the fact that the data centers you're using are thousands of kilometers away and there's a performance issue. Now, luckily for New Zealand, that has been kind of, the box has been ticked there. You can now host things closer to your users in Auckland. Yeah. You then are keeping data onshore as well. So for the compliancy, you might have ticked the box there. So some of the reasons why maybe you didn't use the cloud previously have been removed. I mean, there's nothing stopping you hosting things in other countries as long as it's still compliant and everything, but there might be that performance issue with it. But lots of organizations are going to have a bit of both. They're going to be in a hybrid situation. We're going to have some resources in the cloud, some on-prem, and we can link the two together. If you've made that investment and you've got the hardware sitting there, it kind of makes sense to use it. So having the two is kind of a good option, I suppose. So benefits of cloud computing. We've touched on these as we actually go through, really. It's kind of a more cost-effective solution for most organizations because we haven't got those upfront costs. We haven't got to do all that capacity planning, purchase all the hardware, wait for it to arrive, and then commission it, and then set everything up, and then you've spent all your budget, so you can't really do much with it until you get more budget to maybe expand it and go for it. In the cloud, we just spin up the resources we need. If we don't need them any longer, we can turn them off, throw them back in the pot for someone else. And that works really well for things like online gaming that we mentioned. If you've got a developer developing a game, trying to estimate how much resources you need to support that, if you're doing it all yourself, that capacity planning would be a nightmare. You wouldn't know whether the game's going to fly, whether it's going to take off or not. Pokemon Go was a big test for the cloud years ago. When that first came out, it really took off. Trying to imagine supporting that yourself on-prem would be a nightmare. You'd have to keep throwing more hardware at it, and the lead times for setting up that hardware would be too great. People just wouldn't be able to use the game, and you'd be losing revenue. With the cloud, they can spin up the resources when they need them, and it really tested the cloud vendor at the time. And then novelty factor wears off 4 or 5 weeks later, maybe, and the numbers used in the game drop. You're not just going to be left there with the hardware doing nothing. You can destroy it in the cloud. We've got disposable resources. We can throw it back in the pot for someone else to actually use. So it's a more cost-effective way of actually using it. We're moving from that OPEX to the CAPEX and a consumption model. As an organization, you can focus on kind of your primary function of actually supporting your users, maybe, of offering a service, rather than having to support the underlying infrastructure that actually supports that. So we're passing that control over to the cloud vendor. We don't need to think too much about the resilience element of things, because that's kind of built into a lot of the products. All the networking we kind of do in the cloud is all done through what they call software-defined networking. So when you set up a piece of maybe a router or a firewall in the cloud, it's not one single piece of hardware. It's all done via software. So it's not one single point of failure. So it's got more resilience built into it. Within the cloud, we talk about two things generally: availability and durability. Availability, occasionally the service isn't available. Internet might be down or whatever it is. For the cloud, we're looking at about 4 nines of availability. So 99.99 kind of percent uptime, which is pretty good. But occasionally it's not going to be available. The durability, we're looking at about 9 nines. What's the durability? Well, even if the link's not available, is your data still secure? Will it still be there when the link comes back? And yes, with most services, we're looking at 9 nines. Some of them are even higher. It does depend on the service, and that's achieved because of the way they store the data across multiple locations, and it's kind of replicated and managed for us and kept secure with encryption and everything as well. If you think about banks, occasionally you try and draw money out of a bank. You go to your cash machine, your ATM, not that you use cash much nowadays, and you go and the machine's not working. Now, you don't think you've lost all your money. It's annoying that you can't get your money out, but your money is still safe. You either move to another machine or another method of getting your money out, and your money's still, you wait until the machine's fixed, and then your money's there. The money being there is the durability. The machine not being available is the availability. Now, we can get figures like that ourselves if we manage the hardware, but you've got to spend an awful lot of money, and you've got to have multiple locations and replication all set up to do it. But in the cloud, it's there for us to actually use, as long as we can configure certain services correctly, and we'll come back to that shortly. We've kind of got unlimited capacity in the cloud. I'm sure there is a limit, but they come out with that phrase quite a bit. And we don't need to know how much capacity we need up front, because we can add auto scale. As the demand increases, we can spin up more resources and then turn them off when we don't. They're big organizations. They have a lot of buying power. So when they're setting up these locations, these data centers that we're actually using, they've got a bit of a power behind them. Their unit price that they spend on the actual hardware will be a lot better than we can get. So they've got that economy of scale, which gets passed on to customers, of course. We've mentioned speed already. We've got disposable resources. We can spin something up. If we size it wrong or get it wrong, we're not stuck with it for the next 3 years or 5 years because we've spent our budget. We can just destroy it and start again. And if we destroy it, we're not going to get charged for actually using it. It's just the consumption that we actually get charged for. We can automate. We can go global in minutes. We can go through all the idea of good practices with the CI/CD pipeline, and the idea that we have a development area, and then once we've gone through that, we can go to testing and then eventually to production. And we, rather than having to repeat and do things manually, we can automate the change. So the speed comes down. We can go copy what we've done already into a different location and have that bigger footprint. We can go global very, very quickly. So all that is a big benefit for AI. All these have kind of helped AI get to where it is now. We've got that scale. Now with AI, and we'll explain more later on with this, it's moving away from traditional programming. and coding. When we used to write codes years ago, every possible combination of the output had to be programmed in to the code. Yeah, all those different decisions we made, yeah, all those constraints, the if then else type stuff, everything had to be programmed in. With using AI, we don't. We're training it on data. It's picking characteristics of the data. So when it sees data for the first time, it can use its experience, its training to actually do something with that particular data, classify it or whatever we're trying to do with that data. Now, to train these models in the first place, you've got to handle vast amounts of data, and we need lots of compute to actually process that data. And that's the key thing that we've got in the cloud. We've got this scale at a reasonable price as well, of course. We've actually got specialist hardware now specifically for AI and machine learning. Yeah, so we've got CPUs and we've got different architecture. We've got things like GPUs now for parallel compute, graphical processing units. We've got TPUs as well, which is tensor processing units specifically for machine learning and AI. Within the Amazon, the AWS, Amazon Web Services area, we've got special chip types called Trainium. In fact, we've got Trainium version 2 now, specifically designed for working with AI and the demands of AI. So we've got that capacity, we've got that hardware to actually do it now. If you start using the cloud, what it really is a series of services that we can utilize to build a complete solution. And we have that ability. We can store lots of data in certain formats, whether it's structured or unstructured format. We can link in with all the permissions and the auditing side and the monitoring services that we've got within AWS. So we've got that complete solution available to us. Cost, we've mentioned that one. Yeah, we can spin things up very, very quickly. And if we don't want them, turn them off. So we're not going to get charged too much for them. So we have that flexibility. And we're moving from that big upfront costs, the OPEX model, to the consumption model, we're moving from the CAPEX model to the OPEX model, so pay-as-you-go consumption model. We can integrate with big data. We've mentioned that one. We've got a capacity in the cloud to handle all this big data and then the compute power to actually process it and analyze it as well. And we can do things very quickly. Those lead times have been reduced. We can spin resources up, and if they're not right, turn them off. But we can, do that very, very quickly. So all that is meant with the advancements that we've seen, the advancements we've got within AI. As a bit of a red herring, I did then ask ChatGPT to kind of put all that into a nice little timeline or picture. Yeah, and it said, "Oh, do you mean like we did previously?" Because it remembers the chat that we actually had. And I go, yeah, and it generated that, and I thought that's nice. I'll add that into my slide deck. That'll be good. But then I kind of looked closely and went, "What's that?" And I kind of thought maybe it's something I just wasn't aware of. But no, it's just made rubbish up. And this is the problem you've got with AI. It is very much a people pleaser, and it'll try and generate content, but that content might not always be correct. It's this idea of hallucinations. Yeah, it's making things up. Now, luckily, I did spot it, but I thought I'll keep it in because it's a good example. And then I went back to ChatGPT and said, "What is it?" And it came back and went, yeah, it's a generation error. Didn't apologize, of course, and say sorry, just said generation error. Yeah, it should be this. And would you like me to fix it? I went, yeah. And it came back with that. I went, what? It hasn't fixed it. It's still the same. Yeah. So then we tried a third time. But at the time I was using my free version of it, and you're only allowed to create, I think it's 3 images a month or something, and I hit my limit and it wouldn't actually regenerate it for me. So I've left it in, because it is an issue. We've actually been doing this 9 times now. You'd never know from the mistakes we make. But someone spotted yesterday, Netflix is also spelt wrong on that as well. So they've got it right once, and then the second time they got it wrong. So that's another little issue that we've spotted. So you have got to be a little bit careful with AI. Yeah, and it does. Yeah, it does get things wrong occasionally. All right, the journey of AI. How did it evolve? Yeah, I wasn't around in the 50s, but it feels like it at times. But that's kind of where it can be traced back to. Back into the UK, and some guy called Alan Turing was having this idea that maybe we can get computers to work like humans. They didn't call it AI at the time, artificial intelligence. That didn't come until 6 years later. And the first way they tried to communicate with computers was having a conversation through chat, typing commands in. Yeah, Turing. Yeah, again, there's probably a mistake there as well. Oh, it's good, this stuff, isn't it? And they had this idea of a chat box and communicating. Yeah, it's very limited vocabulary that it actually had, but that was the first signs of it. And then it kind of went a bit quiet, really, until about 20 years later, when they tried to design a way that computers can understand natural language. And we started having different programming languages come along. And that was about the time I was doing my degree. And at the time, it was a lot with Pascal and COBOL and things like that. But we're starting getting some newer generation languages that you could basically tell it exactly what you want, rather than just lines of code. Then the big major one we've got there is this idea of the chess games and a computer beating a grandmaster at chess, and that was called Deep Blue when that first happened back in 1997. Then we get into the robotics side of things and everything, and lots of standardization. Yeah, I don't know why cat videos always pop up on these timelines and things like that, but we've got that there as well. And then we've got that advancement that we've kind of got with GPT and that now. Now, if you want to know a little bit more, I've got that link on the GitHub page, and you can go and read the background information with those key events. But that's, yeah, kind of useful, I suppose, and sees how we've got to where we are now. It's the last few years, the last 10, 15 years, we've seen huge advancements in this area. And that's because, again, of the cloud. We've got the ability to manage lots of data, which we need to train these models. And we've got lots of compute available to us for that process. And it's reasonably cost effective. So I'm not using the word cheap, but yeah, yeah, it's kind of cheap. So we've got the capacity and the technology to actually do it. We've also got other things happening, like billionaires with lots of spare cash that want to get involved in this area. So we're seeing some investment in this area. We've already mentioned we've got the technology, we've got the capability to do it, something that wouldn't have been available 15, 20 years ago. And because of the cloud, we've got the platform that we can actually get and play with very little upfront costs. We haven't got to go all that CapEx expenditure to actually set up a solution. We can spin things up in the cloud and use the cloud, and if it's wrong, we can destroy it again and go through it. So that's kind of where we are at the moment. If you do sign up to this 6-week course that's been kind of subsidized by AWS, this cloud up for the AI practitioner stuff, then you've got a lot of online content. Yeah, and you've got kind of 6 weeks to go through that online content. What you also get each week is a session with an AWS trainer, probably myself or James, and we can ask any questions that you've actually got regarding the content that you should have learned that week. We also do an exam prep as well, so guidelines for doing the exam, and you get a voucher for then, so you can sit the exam. And if you're one of the first 200 to pass it, then you'll get a t-shirt as well. The t-shirt's probably nearly $49 worth on its own, but it's pretty good value. What they do with the online content is they give you bits of videos and bits of text and everything, but they also give you some review questions every so often to make sure you understand what you've just covered. And this is kind of one of those questions, but it's actually taken from the general cloud course and not from the AI course, but you get this sort of thing. In the exam, you would also get multiple choice questions, but they'd be a little bit, yeah, harder than this one, probably. So what is cloud computing? Yeah, and you can join in, you can answer in the chat as well as we go through here. With some of the sessions people have and others they sit there, but have a look. If you want to put an answer in, you can do. Is cloud computing backing up files that are stored on the desktop and mobile devices to prevent data loss. Now, that is one feature of the cloud. We can do that. We can create a hybrid environment and copy content over to the cloud for backups and archiving and what have you. But it's not the sole purpose of the cloud. So it's kind of, yeah, a little bit right, but not maybe completely correct. Deploying applications that are connected to on-premises infrastructure. Well, we can have a hybrid environment between our on-prem and the cloud. That's possible. But again, it's not the main use of the actual cloud. So I'm kind of thinking not A and B yet. Using on-demand delivery of IT resources and applications through the internet. That sounds a bit more like what the cloud is. Yeah, I better check D as well. Running code without needing to manage or provision servers. That's one aspect of the cloud. We can build solutions where Amazon or AWS manage that hardware for us, and we don't have to manage it. We don't even have any connectivity to it. They generally call that serverless solutions. It does run on servers, but we don't actually manage it. AWS are going to manage it for us. Everything runs on servers at the end of the day. So yeah, C would be the best answer for that one. Just another quick question. Yeah. What does scale of the cloud compute, or how does the scale of cloud computing help to save costs? Again, A, B, C, or D. Just got to pick one. Practitioners do not have to invest in technology with the technical resources before using them. That's true of the cloud, but it's not really anything to do with scale. The aggregated cloud usage from a large number of customers results in lower pay-as-you-go prices. Yeah, they've got that buying power. Unit prices are going to be cost effective for them. So those savings should be passed on to the customers. That sounds a bit to do with scale. Better check the others just in case. Accessing services on demand helps prevent access or limited capacity. Well, we've got that scale. We've kind of mentioned that one in there, but it's not to do with cost savings. I mean, okay, you only spin up the resources you need, so maybe we're getting close, but yeah. Practitioners can quickly deploy applications to customers and provide low latency. Again, a good advantage of the cloud, but nothing to do with scale. There's maybe one answer that's more correct than the others. I'm going to go for B for that. B. So, what have we got within AWS? How do they offer services to us? And then how can we utilize them for AI and everything is what we're going to have a look at in this section. And then later on, we'll get more deeper into AI and how we actually work with large language models and into prompt engineering as well. So AWS are all over the world. They've got data centers all over the place. They link that together with their own networking, of course, and then we can spin up the resources we want in all these different locations. But some of the terminology is what we're going to look at and some of the advantages. The one thing we can do in the cloud, and they kind of encourage, is rather than if you need to make something bigger, you scale it up, you make that one resource bigger, we should scale out and have multiple resources. Now, both of them are going to increase the capacity, but if you've only got one of something and you make it bigger, at the end of the day, you've still only got one. It's still a single point of failure. Whereas if we can scale out and have multiple, if one fails, we can always use the others still. And what you do get with, again, the online content, they try and kind of place it and give you little scenarios. And this is that kind of scenario that is one of the advantages of having a global footprint. If for some case you can't get to one of the resources, but you've got others in different locations, you should still be able to get to the other instances. And you can divert the workload to those so you can still continue to work. We have greater resilience within the actual solution. And this is a coffee shop in this example. So if for some reason you can't get to one coffee shop because the power's off or there's in this case, a parade and the roads are shut, you could always go to others if they were available. So this is that advantage of scaling out. And that one thing we can do across multiple locations in the cloud. So how the terminology for all this, what do we actually get and what have you now got in New Zealand? So beginning of September, AWS launched this New Zealand region in Auckland. It goes by the reference of Asia Pacific AP Southeast 6. It's the sixth one in that particular part of the world. If I click on the link, we can go and have a look at it on their documentation. And if I scroll down, they've actually got 38 regions dotted around the world. Yeah. And those regions are then broken up into different locations. Now, I can view different areas here, but if I scroll up, I can go straight to Australia, and the world spins round, and New Zealand. And we can see we've got Sydney, yeah, and Sydney was launched in 2012. Then came Melbourne, and that was launched in 2023. And then we've now got New Zealand. Yeah. Where exactly? They don't advertise that one. We know it's in Auckland, but you're probably a bit like Perth, and we're quite small. So you've probably got a good idea where it actually is. But the region itself is actually not just one single location. It's made up of a minimum of 3 locations. And those 3 locations are called availability zones. So every single region, every one of those 38 regions currently is made up of multiple locations called availability zones. And that is what's giving us that resilience. We can build resources in any of those different locations, in any of those availability zones. Yeah. Those availability zones themselves are actually made up of 1 or more data centers. So it's a bit like Russian dolls. We've got a region. Inside the region, we've got availability zones, and inside availability zones, we've got data centers. Some of the big ones in America, they've actually got 6 or 7 availability zones. So 6 or 7 different locations that we can build resources in. Yeah. Always a minimum of 3, though, that we've got. We've also got what they call edge locations. Edge locations is where we can jump onto their backbone and access their network, and we can utilize some services that sit at the edge of the cloud. So it's a kind of a point of presence that they've actually got. We've got caching services, content delivery networks, and DNS services, and web application firewalls and things like that available at these locations, which is handy because I'm stuck in Perth and it's still quite a long way from eastern side of Australia, of course, but there's certain resources that are available to me in Perth to actually use. So there's a little example. This one is actually in America. So again, that order that we've actually got, we've got a region, and this is US West 1. And then in there, we've got multiple availability zones, and they've got the different letters at the end, A, B, and C as a minimum. And that is then made up of 1 or more data centers, all linked together by their own networking. And yet again, we got another one here, this time in South America. And this one is SA, East 1. And again, we've got 3 availability zones, A, B, and C. And then inside there, there'll be 1 or more data centers. We cannot pick individual data centers that we want to host our resources. The only thing we go up to or down to is availability zone level. Yeah. If I go to the console, so this is one way of interacting with your environment inside AWS, and you can set up an AWS account free of charge. I'll give you the link for that shortly and have an actual play, and then you can spin up all these different resources. There's about 300 and some odd different services now inside here that we can start playing with, all doing different jobs, different roles. At the top here, it tells me that I'm actually connected to Sydney, but if I click that, it will give us a list of all the different available regions that I can use. Now, if you've already got your AWS account created, you might not see New Zealand in there until you actually make it active. And there's an option down here to manage regions, and you're going to make sure that that region is active for you, and then you can spin up resources inside that particular location or multiple locations in those availability zones. So I've actually done that, and I can switch over then to that particular region, and I can start building resources if I need to in New Zealand. Which region would you choose? Why have you got different regions, and what would be the reasons why you put resources in one region over another? Well, you kind of want good performance, so you want to pick one that's pretty local to you. And you've now got one in New Zealand. You might have data sovereignty and governance and compliance issues, so you want one for that. So again, that's tick the box because we've got the one in New Zealand. Different regions do cost different amounts of money. The pricing differs. And thinking logically, they've all been built at different times. They're all in different countries that have different power costs, labor costs, land costs, and that's always going to affect the actual running costs of the different regions as well. So that will reflect in the price. There's another thing to be aware of, that not every service is available in every region. Now, again, you can imagine that architecture from 2012 is going to be completely different to what they've just released now and open now. So it might not be able to support certain services in certain regions. When they bring out new services, they tend to bring them out in a subset of regions first, and if it goes well, they phase them in. They'll then bring them into different regions. So at any one time, some services might not be available in certain regions. So you've obviously got to pick a region where that service is supported. Yeah, so there's different factors of why you'd pick one region over another. You might want to pick a second region as a bit of a backup for the primary region. So you've got even more resilience within your solution. But the main ones are going to be those first ones, yeah, based on the performance, the latency issues, the distance to that particular region, and also for the data sovereignty with the governance and compliance side of things. So bearing all that in mind, before we go for a little break, we're going to mention some of the services that AWS actually support for hosting AI inside their cloud. And that can be broken into two areas. Ones that are ready to go, that you don't need to actually do any configuration. Yeah? So almost like software as a service solutions. We're generally, or your developers, if they want to use those services, would pass content to them through an API. And the service will do what it needs to do and pass the information back. Now, as a training tool, and to see exactly what those services do, we can actually go into the console and view them in the console and see what they do. But normally you'd probably be accessing them, you would be accessing them through API calls. We've also got some platforms or services, suites of services, in fact, that we can use to actually build our own solutions from scratch. And these can be what they call serverless, so we don't have to think about the infrastructure they're actually supported on. But we can then, if we need to, build our own actual solutions. So we're going to have a look at those areas now. We're going to look at some use cases for them. And then when we come back from the break, we're going to go deeper into AI and what it's all about and how it actually works. So one of the first services, they're in no particular order, these, is recognition. And recognition is working with images. We mentioned earlier, there's different areas that generative AI can actually be used for. Yeah, one of it is to play around with images and videos nowadays as well. And we can identify content in there. We can identify objects. We can look for people and face recognition. We can compare images. We can extract content, text and everything from images. And all that functionality can be done within recognition. And it's been trained. It's all ready to go. We don't have to do anything with it. We can just upload some content and it'll do what it's got to do and give us the answer at the end of it. The use case that I kind of picked to explain this and go through this was a company called SmugMug, and I've not heard of SmugMug. And I thought, I don't know if I want to use this. I've not heard of them. But then when I read further, they actually own Flickr now. I don't know when they bought them, but they now own Flickr. And if you've not come across Flickr, if you take any photographs, you can upload those photographs into the cloud and people can share them and access those photographs. Now, the company needed to make sure people that were uploading content that could be offensive, yeah, that hits certain requirements. So it needs to be moderated. And that's one of the functions that recognition can do. So all their developer needed to do, rather than develop a solution themselves, was before the information was uploaded, pass it on to recognition. It does its checks, and if it passes them, then we can upload it. If it doesn't, we'll block that upload. So we got some safeguards in there. And there's a little message there from the CEO. Again, those links, if you want to know more about that use case, are on our GitHub page, so you can read all the information behind it. What I can do is show you a bit of a demo of that as well. Yeah. So if you've got an AWS account, you'll be able to play around with this and have a look at this as well. If you haven't, we'll show you how to set up a free one, so you can have a look at that later on and go for it. Now, because I've been running this presentation a few times, I've got it pinned, or it's on a recently visited option. If you've not used the console before, the other option you've got is you can search to find things, or you can pin it as a favorite. Now, I'll just click on the link there and it will take me into recognition. Yeah, we've got links to documentation and other useful bits and pieces there, but also down the left-hand side, we've got areas where we can do little demos. We can test it and have a look at it. Now, you wouldn't normally access it this way through the console. You'd do it through API calls, as we mentioned, but we can check it. Yeah, they've even got preloaded images that they analyze, and they can pick out objects. Yeah, and we can see wheels and cars and different bits and pieces, skateboard, a person, and you'll get a list of what it's found, and the percentage number at the side is how confident it's been labeled correctly. Yeah, and as you scroll down, you can kind of see the reliability bit. Not quite sure whether 100% correct or not with some of this information, but it's analyzing that picture. Now, that's already done. Yeah, I haven't had to program anything in. It's ready to go. We can just send content to it and we get the answer. In fact, we can upload our own picture and check it now. So I've just got a picture that we grabbed off the internet. You might recognize it. And it'll analyze that picture for us as quickly as that. And again, I can go down here and work out what it's actually detected. And it highlights some of it. We can see the boats and that in there. Some of it we kind of think, yeah, correct. There's a bit of a mistake. Yeah, we got a lake. I can see why it thinks there's a lake, because you can see the water there is kind of surrounded by land, but I'm pretty sure that's going to be a channel, and that's going to be a channel as well. So maybe, that one isn't quite correct, but that's probably why it's down at 55% confidence level on it. But that's one of the features that we can use recognition for. It can identify content inside a picture. We can also look at the makeup of the picture and the different colors that we've actually got in there, the percentage of those colors that make up the picture. Could be useful. Yeah. This is the one that SmugMug used for. We can do image moderation, and you can kind of now do it as it is, and it'll analyze it and say whether it's kind of fit for purpose and whether it's in there that information that people might get upset with, or you can now customize it, and so you can pick certain information that you're looking for in the picture to work out whether it's suitable or not. I can view the content and it'll analyze it and tell you whether there's anything in there that might be offensive, adult content, whatever it is we're actually looking for. And again, if you want to test it, you can upload your own pictures and work it all out. We can use this service to do facial recognition and pick the face out, so then we can use that as a kind of security option, of course, not just on static images but also on video as well. Yeah, we can do a comparison to work out whether it's the same person. So CCTV cameras and identifying people. We've got a still from a CCTV, we've got an image that we've already got on record. Is that the same person? Yeah, and analyze that. It's even got celebrity recognition. I'm not quite sure why we want that one, but yeah, we got celebrity recognition on it as well. We can identify text, which is fair enough, and then we've got another specialist one: identify safety gear, personal protective equipment. And I was thinking, what's that for? Well, maybe you've got some legal requirement that your staff should be wearing their safety gear. Yeah, so we can kind of link that with videos and CCTV and everything, just to make sure they are wearing their safety gear. So there's different use cases with it. I say normally you wouldn't reference it through the actual console and upload it manually. You'd reference it through your API calls and upload content and get your responses that way. But that's the service we've got. That's one of many. Another one we've got is comprehend. So that previous one where recognition was doing images, this is now working with languages and analyzing text, summarizing text, trying to work out whether feedback is negative or positive, trying to get that sentiment, just trying to pick certain main entities, key entities from that actual text, and that links in with summarizing and things as well. Now, the example I've picked out for this one is the UK government, where you've got to basically register the fact that you own the land. So there's a part of the government land registry where they're collecting documentation off people. Now, the first line of defense is you've got to fill a document in with certain key information. And rather than someone having to manually check that the information is correct in the document, and if it isn't, sending it back, that can be now fully automated with AI. And that will hopefully speed up the process, offload some workload to different people as well. Now, everything that you do in our IT should be a project, and we should have kind of, what we're trying to achieve, the outcomes and checkpoints and everything else, so we can work out whether it's been beneficial and all that sort of stuff. But they've got some stats there that they reckon, the review time's been reduced by 50% and staff are more productive. Okay, let's have a look. So we can go back into the console. I've lost my little shortcuts now, but we can go back via the waffle, but I can also type it in here as well. If I put enough letters to uniquely identify it, we should see we get comprehend. And we can upload text, handwriting as well, and it can analyze it. We've got an option here to do real-time analysis, and it gives us some text. Now, again, you can upload your own and check that out. And it'll work out what we've got. So if I hit analyze, it identifies the individual elements that we've got in there. It picks out the key phrases. It knows that it's English. Well, it's almost 100% confident that it's English. We can identify personal identifiable information. We can get the overall sentiment of the message, and we can then fine-tune that and look at the individual elements of it and get the sentiment and just the general syntax that's actually used. And again, we can change that and get that information back, but we're analyzing it. You can customize what it's looking for in there as well and identify different bits of information. Again, you wouldn't normally do it through the console. You'd integrate it through API calls. Gives us the information there and the feedback you get back. So that's where the developers would link into it. We got translate. That's an easy one. We can take one language, translate it into another. And you think, so what? Well, we can do it in real time now. I was lucky enough to go to Japan beginning of the year. I've got one daughter traveling the world at the moment after doing her degree and picking up jobs all over the place with her boyfriend. And she was at a ski resort in Japan, so we went over there. Most of it is English now, isn't it? The menus are all in English as well as Japanese, but occasionally you go to somewhere and it's not. But you've got a little translation app on your phone. You can use the camera on the phone. You can show it the menu, and instantaneously it translates it into English for you. I was really impressed. The wife was not so impressed, but I said, you haven't realized what's going on in the background. There's different forms of AI being used here. It's managed to look at the image. It's identified the text, Japanese. It's taken that Japanese, it's converted the equivalent into English, and then regenerated the image. And it does it in kind of like a second. It's just mad. And it's free to do it. Well, Translate is the service we've got in AWS to actually do that. And the example we got, the use case, is Fujitsu. And you kind of think, okay, global company, they're going to have support teams dotted all over the world to handle with any issues you've got. But then you think, hold on, if they're across multiple countries, each of those countries has their own language. To offer support, these technical guys have got to be able to speak different languages. That gets tricky. So you kind of need one per country with different languages. And that, obviously, not brilliant. It would be nice if you could put all your experts in one place, and you got that scale, but then they've got to be able to speak multiple languages. Well, they don't now because we can have translate on there. So as customers are communicating with them, it can automatically translate the conversations. And because they're experts in their area, they should be able to handle the issues that they're actually dealing with a lot quicker. But they've also got economy of scale. We've only got one sort of central global service desk as well. And that's exactly what Fujitsu have actually come up with. Now, you probably, you must know what translation services do and all that sort of thing. But I've got a little bit of text that we can just get translated here. So if I just copy something Bang. And then we can go into translate. And you can enter your text. And straight away, it translates it into English. In this case, you can change your different source and destination languages, of course. And again, normally you wouldn't do it through the console. You'd be able to do it through API calls when we got the application integration at the bottom. Now, I could have picked the language in the first place, but it's automatically detected that that is French and translated it. It's kind of what you'd expect. But straight out of the box, it's already been trained. Everything's ready to go to actually use it. To extract, that's a made-up word, isn't it? We can extract text from documents. Yeah, again, handwritten as well, scan documents to actually do it. And the example we've got here is NIB, which are in New Zealand as well as Australia, private health. Yeah, but people have to claim money back. So nowadays they've got an app on their phone. They can take a picture with their camera of a bill, and it'll extract information from there and start filling in the claims form automatically. Now, I've actually come across this recently myself, not with NIB, but with an expense system called Concur. People might use it. I haven't traveled for a while, not been using it much, but the other week I went over to Melbourne to deliver a course, and I got all the receipts. Yeah, and I took pictures with my phone and everything. And when I uploaded it to Concur, it automatically extracted the information from the picture and started populating the form for me. It's like, wow. Yeah, I haven't checked, but I'm pretty sure under the bonnet it's going to be using Textract, which is what NIB are doing. And again, if you want to know more information of that use case, then check out our GitHub page, and I've got the links in it there. But again, we can do a demo in the console. If I go over, yeah, we can type in text track. Made up word, isn't it? And we've got a demo area here, and we can analyze an individual document. Yeah, so there's our little document, some kind of a receipt, pay stub, as it says, and we can extract certain information. Yeah, just the general, all of it. Yeah, we've got all the layout. We can fill in certain form content from it, put it into table. We can query it and ask it questions to grab the information out, and we can identify signatures. Yeah, we can use it for expenses, which is what Concur does. So there's a receipt. Yeah, and straight away it can extract the key elements from that, and then we can put that into other forms, other data stores that we're actually going to use. Yeah, we've got one for analyzing ID, yeah, like a driving license, and picking out the key information from there. The lending solution is actually putting it all together into one solution. So if you're trying to get a loan from the bank, there'd be certain hoops you've got to jump through. You got to prove your identity. You've got to supply pay slips and bills and all that sort of thing. And that can be fully automated. Yeah. Here we go. So we've seen we can handle documents and extract data from there. We've got pay slips and things. We need to make sure the signature's correct, that we've got enough forms of identity to identify the person. We've got then bills and bank statements and all that. And all this can be checked through AI. Not just once, we can also do bulk loading and that as well. But again, generally, we're not going to go through doing it through the console. We're going to do through API calls to actually do it as well. There's a search engine, an intelligent AI-based search engine that we can take data from different data sources and combine, and then create an index, a catalog of that information, and then actually use that to find the content. Funny enough, and that's called Kendra. And it takes a while to build the actual index, so I won't do that as a demo. But the use case we've got is BMW. Most car companies now have online manuals, part of their kind of their screen system, their in-console system, and it references lots of different content, lots of different documentation, and you need to be able to search all that information, and that's the job that Kendra can do. So you create an index, you pump all the data into it, and it generates it. So when we can use it to search content. Example BMW. Transcribe. This is where we're, again, communicating, but this time we're turning speech into text. You've also got the opposite we can actually do. So the big use for this one, of course, is things like closed caption or subtitles that we can do pretty much instantaneously on the fly. And the use case we've actually got is Formula One, which, you think about it, is quite impressive because those commentators do get quite excited at times, and they've got certain dialects, and it can understand them and translate it into text in different languages if we want to as well, pretty much instantaneously. And there's a quote there from one of the digital heads, but yeah, again, more information about that on our GitHub page if you want to know more about that one. The other way around is turning text into speech. And this is like audiobooks and that sort of thing. And the service that does that inside AWS is called Poly. It's probably got something to do with parrots, of course, to actually do it. And the use case we've got, Washington Post. They publish articles online on their news sites. Straight away, as soon as it's published, it automatically generates an audio version of it, an MP3 file, using Poly. So maybe people with sight issues and everything can listen to the story rather than having to read it out. You've also got communication through voice, and that's through a tool called Lex. I guess this comes from Alexa and the idea that you can communicate obviously through that device, but you can have conversations, so chat box and everything. Now, the example we've got here is Dropbox have put one together for their customers, again, across different languages, across different countries, and it scales because it's sitting on the cloud. It's a serverless solution that we can just integrate with through those API calls. When you build the environment in Lex, rather than having to start from scratch, they've actually got some pre-configured templates and that you can actually use, scenarios that have already been created. So rather than having to train them with certain specific words for certain use cases, we've got templates here, and we've got lots of phrases that are used for the chat boxes in the different industries. Auto industry, airline, telecommunications, retail. So it already knows those key words that are going to be in there and understands them, so we can then set it up as a chat box solution without having to build anything ourselves. If we do want to build solutions ourselves, and sometimes we do, then we've got a service inside AWS to actually do it, and that's called Bedrock. And this is a no-code or low-code solution where we can take pre-configured AI engines or foundation models, and there's hundreds of them nowadays that we can actually use, and tweak them slightly to work in our particular use case. So these foundation models, some of them are owned by Amazon, AWS, others are third-party ones that we can use, and they tend to be written for different use cases. So some of them have got a medical bias, so they know all the medical terminology. Some of them are going to be for legal. Some of them are going to be for images rather than for words. Some of them are rather large, so they're very good at getting really good answers, but they take a while to do it. Some are more lightweight because sometimes you want an answer very quickly. Things like self-drive cars and that, you don't want to wait too long for an answer because you'll hit something. So there's different size models and everything that we can actually use. Some of these models are closed models, we can't change them, but majority of them we can actually install them, and then we can tweak them to work better for our particular scenario. We can change some of the parameters that we've actually got inside those models. When you think, when we're talking about AI, and we'll get more of this after the break, computers work in numbers. When we're talking about AI, what's really happening is a lot of maths and statistics and probabilities. When it's generating sentences, there's only so many words that can come next in the sentence. And it's all about probabilities and that. We can tweak, but the maths, they're actually used with some of these foundation models. So we can change the output they're going to generate. We can change the size of the output as well. We can augment these models with our own data sets. So rather than having to retrain them to work on a different data set, we can just stitch our own content on top of them. And that's the idea of setting up knowledge bases.
Yeah. We can protect the model from answering certain questions. We can restrict, control. Yeah, there'll be certain areas we don't want it to respond to. How do I make a bomb? Yeah, we can do that by adding what they call guardrails. And all this can be done inside Bedrock. So before we go for a break, for a 10-minute break, we'll just do a quick demo of Bedrock, and then we'll come back. We'll talk about the other product we've got for building content ourselves, SageMaker, and then we'll get into AI a lot more deeper as well when we come back. So I'm in here. I've got a shortcut for Bedrock, and this is our serverless solution. So once we design a solution here, AWS are going to manage it all for us. We don't need to manage all the infrastructure. It actually sits on. But we can tweak the models before we actually deploy them. So where do we start? Well, rather than starting from scratch, we've got over 100 foundation models that we can use. Yeah. So first thing we need to do is look at the model catalog. And every time you look, these numbers seem to increase. Oh no, it's been 166 this week. That's good. Yeah, all the way through. Now, some of them are already built into this model, this tool. Others we've got to activate first. And some of them are third-party ones, so there's licenses and everything that we've got to worry about there. But there's all these different models, all written for different uses, all been trained on different data, so we'll come out with different responses. So some of them are going to be better for certain use cases than others. But you can analyze and compare and see which model's best for your particular use case. Yeah. Before I can use it, I've got to activate the model. So down here, we've got model access. This is all changing currently. I've only got a few models accessed at a moment, but you can go and modify the access, sign your life away to the license agreement, and then you can actually start playing around with those particular models. Now, where I can play is in this area called Playground. Don't call it demo, they call it Playground in here. So we can choose what we want to do, whether it's just a single question or whether we want to chat to the model. And then we can select the model. Now, I've only activated a few of them, so we'll just pick this one. We'll pay on demand as we go. And that opens up the model. So now I can type in a prompt. This is just a testing ground to do a demo. Yeah. Again, normally we'd access it through APIs and go for it. Now, this is a Amazon AWS one. So I can actually tweak some of the parameters. I can modify the output it's going to generate. Yeah. First of all, I can change the length of the answer. Now, the bigger the answer we get, the more compute power it's going to take, the longer it will take to do it, but the more it's going to cost me as well. So we can change it. Now, we'll explain what tokens are when we come back after the break. But if we change the slide bar less, it's going to give less of an answer, but that's going to take less resources as well. It's a trade-off. We can get it to stop doing an answer at certain key points, at a certain stop signal, like a full stop at the end of a sentence. We can add that in there to cut down the response. Then we've got how we manipulate that answer itself. Yeah. Now, some use cases, we want the actual generative AI solution to generate a completely different answer every time. Yeah. Give me a story about a dog in Perth, and it will write a story. Yeah, you might want to give it a little bit more randomness here, so it has a little bit more freedom on what the actual story is about, or we can tweak it a bit so it's a little bit more rigid on its answers. And that setting we got is temperature. If we increase the temperature, we're giving it a little bit more freedom to bit more kind of fluffy answers, if you like. But it kind of depends what you're using the model for. You might be using it as a bit of a Q&A thing, and you want it to kind of be more standardized on the answer, in which case you would lower the temperature. Yeah. You may also be able to change the maths it used to calculate the next word in a sentence. And the two main parameters we got to change that are what they call top P and top K. Now, when you do the Cloud Up course, the AI practitioner, that gets explained a little bit more detail. But one of the options, we're just picking out the next possible words out of the list. So you're ticking 10 of them that are available without taking probabilities into it, whereas the top P, we're looking at the probabilities. So one might be 80% probable and the other's only sort of combined 20%. So we can change the percentage marks that we're actually choosing the next word with that we're going to get the answer generated. Now, that will vary what parameters we can use on the different models we pick in the first place. Yeah. So I can write a question in there, a prompt. Yeah. Should I invest in gold? And it will come back and probably say, I can't give you specific advice, but here's some general advice. There we go. Gold's quite expensive at the moment. Whether it keeps going up or not, I've got no idea, but it's come up with an answer for us. Now we might want to stop the model from actually answering those questions. How we can limit what the model answers is guardrails. And I've got one that I've prepared earlier. So I can add a guardrail to this and we can just check it first before we actually make it live and then use this. And this guardrail is going to stop things that anything to do with financial advice. Now there's other options, obviously adult content and all that sort of thing in there can be stopped as well. So if I do a similar type of thing now, should I invest in housing? Now, rather than giving a very generic answer, which that one did, this should hopefully be blocked completely. And we get a customized message that you can change that says, sorry, the model can't answer that. So we can limit, we can tweak things. So we're using foundation models, pre-configured AI solutions from AWS and potentially third-party ones that we can make available as well. Some of them we don't have to use as is. We can tweak how they generate the answer. Change those slider bars that we've actually got there. And we can also control the answer. We can stop it from answering certain areas. Now, if I go back to the menu at the side here, there's guardrails, and that's where I created the guardrails, and there's pre-configured templates we can use to stop adult content and all that sort of thing in there. We've chosen the model down in the settings and done the activation of the model. What we can also do is supplement this model with our own data sets, and that's using knowledge bases. So I've got technical documents that we might want AI to answer based on the content of those technical documents. Now, the models themselves would have never seen that. They've never been trained on that data. I don't want to have the hassle of retraining them from scratch and actually embedding that data into their data sets. But what I can do is supplement it, augment it. And this goes under the phrase of RAG. And I always forget what RAG stands for, retrieval augmented generation. And we can actually store that data that we want it to supplement the actual model with in either structured or unstructured storage inside AWS. And it will then query that information and supplement the answer with that information. So we get a more precise answer, a more unique answer for our little use case. And all that can be set up in Bedrock. And once we're ready, we can expose it and make it available through APIs. Do we manage the hardware it runs on? No. AWS are going to manage it for us. It's what they call a serverless solution. We don't have to worry about that infrastructure to actually do it. Now, the example I've got of a company that used it is HubSpot. And that is basically a collaboration company. And they got basically chat going on in there, chatbots and things, and it's got to pick data from different locations, and they've used pre-configured foundation models and augmented it with their own data sets and actually then limited the connectivity through using these guardrails. And again, more information about that one on our GitHub page. Probably a good time to take our break. When we come back, we'll mention SageMaker, and this gives us the ability to build our own solution potentially from scratch if we want to. And then we'll delve deeper into AI and some of the bits we've sort of mentioned already, but adding a bit more meat to the bone. And also having a look at prompt engineering as well and kind of what we got in the future for all this. So I'll put the clock on. I'll leave the meeting going. We'll mute ourselves, of course, and that, but we'll come back in 10 minutes where we'll continue on. So take a break, stretch your legs, and we'll see you back here shortly. Okay. Hopefully everyone is refreshed after that mini break. Give people a little bit longer just to get back in, and then we'll talk about SageMaker, which is the other platform we've actually got for building your own solution. Now, again, you can use pre-configured foundation models as a starting point. There's blueprints or templates we can actually use to get us up and running, but it can also be used to follow the whole complete life cycle of building your own solution. So it's really a set of tools. It's a suite of services that we've actually got where we can actually put data together to train the models, and then to evaluate, to monitor them, to check all the auditing and governance and everything, and then eventually to publish that as a solution. And this, we have a choice of putting it onto infrastructure that we manage, or put it onto some serverless kind of solution as well. So it's a whole suite of tools. So I think, well, hopefully everyone's back now. So we'll talk about SageMaker. It had a rename a few weeks ago. It's now called SageMaker AI. But when changes happen in the cloud, you tend to have to opt into the new one first, if you're using the existing one. And then eventually the new one becomes the default. And if you want to go back, you've got to opt into the old one. And eventually they'll remove the old one. So currently we've kind of got two if you like, consoles to actually play around with this particular area. But I'm sure eventually it will just be the SageMaker AI that we've actually got. So again, do a quick demo. If I type in Sage, you'll see we've got SageMaker and SageMaker AI. So if I go into the old one, we can see how it used to look, and straight away there's a message saying, go to the new one. So go to the new one. I'll have a look at it there. So this is a series of tools we've actually got for building our solutions. Again, we can use kind of a low code solution. So we can actually open up a drawing area, a canvas, and start dragging and dropping and putting content in that way. We can bring in solutions from third-party options as well. First choice, are we going to actually build a solution ourselves, or are we part of a team? And we've got to share content, in which case we can share it within an organization. So you've got a choice of setting up as a one user kind of solution, or as a team of people, and then you've got to sort out all your permissions, and we've got options to delegate permissions at the side here. We've got Jumpstart. So we've got these pre-configured foundation models that we can use as a starting point. And we've got templates that we can actually use. And again, we can create solutions to do with imaging or to do with language in here. We need to look at the governance side of things and making sure that the models are compliant to certain standards, and we can pull out information about the different models and see what compliance levels they're actually compliant to. That's all through the model cards and that. We can use it to generate our own content, so we can create data to test and actually train the models from scratch. Once we've trained them, we can then evaluate them and compare them against others. And when we're happy, we can start thinking about publishing them and how we're going to publish them. So the whole life cycle we can actually manage within this tool, but we don't have to start from scratch. We can use these pre-configured foundation models again. Or if we want to, we can start building our own. We can cleanse the data to make sure the data's good for actually training it. We can evaluate it. We can continually monitor as well. We can run standard tests against our solution to see the response it gets. So we can ask manually certain questions and just manually check the answers we get, but we can also use what they call benchmarks and we can check certain models with pre-configured questions. And we know what the answer should be and compare the answer with that particular answer the model gives us. So there's all different ways that we can use to actually build a solution in here. The example we've got, the case study that we've actually got, is from Toyota, and they've used SageMaker to build their own solution. So maybe those out-of-the-box solutions we've got, they don't hit the requirements. They're not particularly trained on the right data sets, maybe. They're not specific for your use, or maybe they don't hit governance and compliance because we don't know exactly how they were trained. So we want to maybe train our own models to satisfy that requirement. There's all different reasons, but we have that ability. So within AWS, we can spin up services that are already pre-configured to actually use, but we can also use Bedrock and SageMaker to actually build our own solutions as well. Maybe not from scratch, but maybe using those foundation models. If you want to play with any of that, you will need an AWS account. There is options. I think since I put this slide together, they've actually increased the credit to $200. I think James has already put that link in chat. Thank you very much already. Free tier, yeah. New customers now get $200 in credit. So some services you kind of get free for 12 months. Others, there's a limited usage that you get for a period of time. Anything else you're going to have to pay for. But if you set up a free one, you do get $200 US dollars of credit to play with that environment. Don't think I need to share that. It's on the GitHub page anyway, if not. A couple of other useful ones that you might get interested in. You can use AI to generate AI. So within a tool called PartyRock, you can actually generate some AI applications to do certain tasks for you by just giving it some instructions, by entering a prompt. Now this fits on top of Bedrock. It's a web-based service, and you get so much usage, again, free. If you want to use it, it looks a bit dated, but I guess that's deliberate on there. But yeah, you can tell it that you want to do certain tasks and it will build that for you. And then you can share it with other people. You can look at other people's models and or solutions that they've actually come up with as well. I think, again, I've got that on the GitHub page, but just in case, we'll copy it and we'll paste that one down there if you want to have a look at that. Now, if you've got some developers on at the moment, and they've done well to survive that first bit, where we're going to get a little bit more technical now. One way that you can train your models is through a process of what they call reinforcement learning. So you learn basically from your mistakes. We get rewarded for good stuff and we get penalized for bad. And to help you kind of get your head around all that and how that works, AWS have come up with a little competitive thing called Deep Racer. And this is where you can pick your skills against other people, individually or within teams. And you basically got to get a car around a track, something like that. And you go against all these other people, and it basically learns. If it falls off the track, goes back again, starts again, and does something different. So this idea of reinforcement learning. You can buy the little cars and all sorts of bits and pieces in it if you want to get into that. There's 10 hours free with it, so you can have a little play again free of charge. Again, I'm pretty sure I've got that on the GitHub page, but we'll copy it and we'll put it into chat if you're interested. But that's kind of taking it really to the next level. Again, we just threw in a couple of knowledge check questions in here, just to make sure that what we've been saying makes a little bit of sense. So true or false with the, which one's true, I should say, for these particular statements. An availability zone consists of a single region. An availability zone consists of 2 or more regions. A region consists of a single availability zone, or a region consists of 3 or more availability zones. Well, we mentioned, it was kind of like Russian dolls, where you get the one doll inside the other, inside the other, inside the other. You get a region. Inside the region, you get availability zones, minimum of 3. And inside the availability zones, you get your data centers, 1 or more data centers. So the one that makes sense there, which is true, is D. And finally, which factors should be considered for selecting a region? Now, there's lots of different reasons, but yeah, two of those should be, at least two of them, of course. Compliance with data governance and legal requirements. Yeah, keeping data onshore, data sovereignty issues, that's going to be one issue, definitely. Proximity to customers, that's going to be one reason why you choose one region across another. Access to 24/7 technical support, you get that in every region. Ability to assign custom permissions to different users. There's an accounts database that is a global resource that works across all the regions. So it doesn't matter which region you use there. That's called identity access management. And you can use a command line. Well, yeah, we can use a command line interface instead of a console, again, in any of the regions. We can even use PowerShell if we have to, or if you want to actually manage things. There's modules you can download to use that. But yeah, the two that are there, A and B, are the ones that would be decisive factors why you pick one region over another. And that's why you've kind of got New Zealand now. So we're bringing the content closer to the users, and we're ticking the compliance requirements now by keeping information inside New Zealand. Okay, change of tact. We've mentioned AI. We haven't really explained what it is fully. We've talked about generative AI. We've mentioned a little bit about that, but we're going to go a bit deeper and then explain how it actually works and some of the techniques that it actually uses, and some of the issues that that gives us, as well as then looking at how we can improve the output we get from these AI models. So, generative AI, where does it fit in the big scheme of things? Well, the first term we're looking at is artificial intelligence. Artificial intelligence is basically that whole area that we're actually talking about. So this idea that traditional programming, every possible combination of outputs had to be programmed in the code. Every possible path had to be programmed in. So the idea of using constraints and if then else kind of statements and that sort of thing. It is an umbrella term for anything that basically is this different way of working where we're trying to mimic human intelligence, if you like, to actually do it. A subset of artificial intelligence is machine learning. And this is the idea that rather than program the models, we train them and they continue to learn. So we can continue to fine tune and train these different models. So we generate some test data. We give them this data to actually train the models with, and then we analyze to make sure they're actually got the relevant output that we're after. So we're getting it to work more like humans. A subset of machine learning is the idea of deep learning. And this is the idea that we're trying to get it to work very similar to like a human brain works, where you've got a series of points and different multiple paths. So the idea of neurons. And again, one of the services we've looked at already is kind of based around all this, and that's the idea of image analysis with recognition. And then a subset of deep learning is generative AI. And the big difference here is that we're using it to generate new content. So it's been trained on lots of data. So it understands, and then you ask it a prompt, and using that prompt, it will generate brand new content. Be it images, be it text, summarizing stories, whatever it is that we're actually doing. So they all kind of, again, fit inside each other that we're talking. Here's a little issue that we might have. And this is one thing you've got to be careful when you're using these different models, that we're actually getting the answer we expect. And we've seen we're having issues. We've got this thing called hallucination where it makes up answers. But computers have got to somehow understand human language, sentences. And we've got an incomplete sentence here. Now, what the next word will be, different people will have different ideas. And there's more than one correct word that we can put in there. So when we're building these solutions, the models have got to be trained on certain data. We've got to make sure that data is kind of going to give us those answers we expect. that it's not biased to one part of the population or another, that it's actually fair as well. And these are terms that we use inside AI. This could be, the answer could be mouse for most people, but in different parts of the world, you might want to think about a different answer to that missing word. It might be bird. It might be lizard. It depends what, other animals are around. They might be close to a water source and it's a fish. There's all different. It might be a rat. There's different words that we can actually put in there. And the issue we've always had is the computers have got to understand that. And we've got to somehow get them to work with different natural languages. So that was our kind of issue with AI, understanding human language. There is so many different languages out there, and each of them have a slightly different format and different rules for building up the sentences. Computers themselves don't like using words. They're back to mathematics, and in the basic format in binary, electronic circuitry, ons and offs, true or false, yes or no's, 0 or 1. And then we use logic, Boolean logic, ands, ors, nors, not, to combine all this to get outputs. And then you get your half adder and your full adder, and you've got your computer, which is fine. It works. Things are getting a bit complicated now because we're having things like quantum compute and qubits, and the bits now don't have to be just zeros and ones. They can be nothing or both, or it gets really complicated. Computers, though, don't really understand language too well. Humans work in language, not mathematics so much. So trying to link the two together is that issue that we've actually got. So what happened was they developed a technique called large language models. So how computers can start understanding language. We need to turn that language into numbers that the computer can understand. Now, there's different ways that has been done over the years. There's different architecture behind it all, but the main one we use is what they call transformer architecture. There's other architecture for doing different scenarios inside AI. So first thing of all, we've got to make sure the computer understands the questions we're asking it. We've got to break this language into bits that it can understand. And that process is the idea of tokenization, turning the actual sentences into tokens so we can then analyze each element of that particular sentence. Now, a token might be a complete word. It might be a phrase, so multiple words. It might be part of a word. It might actually be a word. It might be punctuation, because by adding a punctuation to a sentence can change the meaning. But we need to break it into these chunks so we can start analyzing that particular sentence. So tokens can be words, phrases, or characters, like full stop. Example, we have a sentence. A puppy is to a dog as a kitten is to a cat. Now, you'll come across this a lot in the documentation for AI. And straight away, we've broken that into, in this case, just individual words. And there's the actual tokens. So we're getting there. We can now start analyzing those tokens. Now, what we've got to somehow do is tell the computer all those relationships between all those words. How does A relate to puppy, and how does puppy relate to dog, and kitten to cat, and all that sort of thing? And this is what's happening when you train these models. The process of actually building in those relationships is called embedding. And again, we're using numbers to represent these relationships. These numbers are stored in multi-dimensional arrays, so we can capture all those different characteristics, those links that we've actually got. So we're storing that information in a list of numbers, a vector. So we break it into tokens, and then it's got all those different relationships stored in it. And this is where we need lots of compute and lots of storage. Of course, it needs lots of data to train it on so it can work out all those different relationships. That's why we don't generally start from scratch and build our own solutions. We're using these foundation models where this has already been done for us. Pictures always help. So what is happening when it's embedding this information and building out these multi-dimensional arrays with this information in, is capturing all those different relationships between the words. The fact that there is a relationship between a cat and a dog, between a cat and a feline, between a kitten and a cat, and a puppy is the same but to a dog, and all that has got to be programmed in. That's part of the training process that's going on. What about images? Images work completely differently. Yeah, we're talking about language there, but what about AI working with images? Well, again, we get different models and architecture that we can use for analyzing images. And one option that they actually use is the idea of diffusion. So we can take an image and from that generate another. That's one of the features that can we do with this AI now, of course. So it uses it by doing a two-step process. It takes an image, scrambles it, and then unscrambles it. Hopefully, when it unscrambles it, it ends up with a different image. And that's the idea of forward diffusion and reverse diffusion. So we start off with an image. We've got a very happy little dog. Yeah, and slowly we add noise. We scramble it. So we can't work out what the picture is. And then when we get to a certain point, we reverse it. We try and remove the noise. Not the same noise is going to be removed, so you end up with a different picture. And that's how we can generate new pictures. I mean, there's a bit more depth and maths and everything behind it, but that's the basic principle behind it. So, what we've done so far, what we talked about, and then we'll get into prompt engineering and all that sort of thing as well. So I'm sure you've come across AI. You might not think you have, but generally, I guess most people have some kind of exposure to it. You've got predictive texting on phones and things. You've got the voice recognition software. You might have a newer car that's got safety aids on it that will keep you inside the white lines and that sort of thing. Brake automatically when you get too close to the car in front. Bleep when you're getting too close when you're reversing. All that sort of stuff. I went to see my parents this year again. They're getting on a bit in the UK. Sitting there one evening watching the news on telly. There was a piece about AI. My dad says, well, I'm never going to use it. I went, Dad, you're using it all the time. He said, what? I said, you've got Alexa in the corner telling it to turn your lights on and off. I said, you've got a car that's got a sat nav on it. I said, that's learning from different live data and everything. I said, you've got driving aids in there, keeping you in the lane and all that sort of thing. I said, that's all AI. I went, oh, yeah, okay. And it is, it's all over the place. We're using it without knowing it. You open up a browser now and type in some search into a search engine and the first response is AI. Yeah, which is causing a bit of an issue now, apparently. I was reading an article the other day about news sites aren't getting the traffic because people are opening up and asking news questions into the browser and it's pulling it out through AI and not actually going to the news site. So they're getting less hits and they're going to get less advertising money then. So there's a knock-on effect for that. We're seeing it in professional life. We've had some use cases already going through companies that are actually utilizing it. We see it when we jump onto websites and chat and everything, and some of those are better than others, of course. We've kind of looked at the difference. So the whole field's called AI. Generative AI is just part of it, and it is the idea of generating new content, and that's it. And the fact we can continue to learn and get better, and we've got some examples coming up of that shortly. What we've got to be careful of is if we're using someone else's solutions, how well are they written? Yeah. Is there any issues with the data that they're all trained on? Have they got certain biases to certain one part of the population than another? Yeah. And we can demo that shortly and have a look at it. We've mentioned already that we can deal with text and summarize text and the sentiment of text. We can use text to generate images or videos as well. We can add voice to text and text to voice. And we can use it as a coding solution to write code for you as well, amongst other things. Yeah. What we've got to be careful of is that AI doesn't always come up with the correct answer. Sometimes it makes things up. We saw that in the diagram earlier. It hallucinates is the phrase they like to use, or the word they like to use. They're people pleasers. It tries to generate content, yeah, and sometimes makes it up. We need to look at how were they trained in the first place, the information they produce, yeah, copyright issues, intellectual property, ownership, and all that sort of thing. We need to make sure we're not exposing corporate data and personal data to these systems, because from that they can learn and improve, but that means they know that information and might give that information to someone else. We're going to make sure the data they're trained with is fair. It's not picking certain biases between one part of the population and another. So the data sets need to encompass all the different possible combinations. The data they give us, we don't always know how it was generated. Yeah. Some of these are like a closed box, like a black box solution. You ask it a question, you get an answer, but you don't know how it generated the answer. Some of them you can tweak the settings so you can change those parameters that will affect the output. But others, it just gives you an output. Is that output correct? What do I do with the output? All those issues. And then there's all the ethics and everything behind it all as well, of course, to worry about. Here's a little example. And this kind of also shows the fact that AI is continuing to get better and learning, continually learning. So within the little workshop that they had a few months back, they actually got everybody to go into their kind of favorite public AI and ask it to draw a diagram from Salvador Dali, a picture. Now, if you do Google or do a search and find out Salvador Dali is an artist from Spain, he went through different phases in his life of producing different content, based on different styles. There's realism, surrealism, and all the different formats. Melting form's a bit weird, but there's different ones. And you think, well, okay, so what? Well, if you ask a certain question, draw a picture in the style of Salvador Dali, it's going to pick one, and it's going to have certain biases to one or the other. Also, there's a few other things we've got to think about as well. There's some examples of those different forms that he actually, or phases he actually went through. So the question, the prompt, create an image of a polar bear in a desert in the style of Salvador Dali. Now, I've got that prompt in my little document here, so I can copy it so I don't have to type it in. And I'm going to open up my browser. And while we're doing the rest of it, we'll let it generate something, so we can get it to generate an image from text now. So we'll paste it in. I'll use ChatGPT, but I could have used Gemini or whatever as well. That will work away in the background. But what elements, what are we kind of expecting to see in there? What expectations have we got? And it'll vary where you are around the world. And we're hoping that it's been programmed well enough with the data initially that it can take that into account. When we first did it, it couldn't, but since then it's actually got better. So we can kind of expect a polar bear. What style, we're not sure, but we could have changed the prompt and named a particular style if we want to as well. So we could have got around that one. And the desert. What type of desert? Now, different areas of the world will have different expectations of what a desert is. If you're in America, it's a bit more rocky maybe and cacti and things. If you're in Africa, you might think more of the Sahara and sand dunes and what have you. If you're in Australia, it's more red dust and dust and more dust. You might be in Antarctica and you think of ice deserts and that. I don't know. But there's different areas. We've got different expectations. The data it was trained with is probably going to be biased to one or the other. And a lot of these models have been trained kind of with that American data set more than anything else. So they may be more biased to an American answer. Now, when we first did this, and this was first done back in February, this one, that was the kind of picture that was generated. And we can see there's cacti, and it picked melting forms as the style, but we could modify that. And there's a polar bear. So you think, yeah, okay, But then when I added this to the demo, and we actually do that live one, and I go in here and have a look, it's getting more and more like that every time. And now I need to check this out a bit more. But as I've kind of created an account now, I'm pretty sure it knows where I am. And it knows that I'm sat in Australia. So it's now got a bit more of a bias to actually using Australian data. And it's actually got more of a Australian looking desert, really. There's no cacti, and there's definitely a red tinge to it. What I keep thinking, I should probably open up a VPN and try and get into Africa somewhere and then ask the same question there and see if it actually generates a different answer based on that. Now, the other way around is trying to fix the bias, maybe, is asking more precise questions and checking all that out as well. But it's just something you've got to be aware of when we're using AI, that it's IT. At the end of the day, it's garbage in, garbage out. If it's been trained on the wrong data, you're going to get the wrong information out. Or if you ask the wrong question, you're going to get the wrong information out. And that leads us to prompt engineering, which is a whole now field in AI, which is all about asking the right question to get the answer you want. Now, the good news is if you don't get the right question the first time and you don't get the answer you want, you can always fine tune it. You can ask another question because it remembers what you've done, of course. But prompt is how you communicate with these AI systems, asking it what to do. And there's lots of little quotes and things like that here that was originally taken from the workshop that AWS put together. And your issue here isn't going to be whether you use the right model to get the answer or which model you use. It's the person asking the questions. Have they got the skill set to get the information out in the format they actually want it? Yeah. And then it makes sense. And again, there's quotes and there's things and these links I've got in that GitHub page as well. So it's the process of communicating the task that you want AI to actually do so you get the right output. That's the idea of prompting or prompt engineering. And there is different types of prompts. And again, it depends on the use case and what we're trying to get. Some of them are very generic type prompts. Others need to be more specific. I mean, you can overcomplicate it as well. But there's some tips on that we've got to get a better job, quicker. You might get there eventually by asking questions over and over again and refining the question, but we want to get there as quickly as possible. And there's things like we can tell it what not to do, which is a good one. But we've got different types of prompts. We've got open-ended prompts, just general prompts. What are the benefits of AI in local government? Now, we could improve that. We could tell it the level that it wants the answer, the amount of information they want generated, the format, more specifically about certain areas of local government, maybe. But we can fine-tune it. But it's a starting point. We can tell it to summarize content. We've seen that. That's a good one. We can upload content to get it to summarize now as well. We can tell AI to act, to take a certain role, a persona. Again, so we're targeting and manipulating that particular output. Act as a city planner. We need to be clear, precise, of course, when we're actually doing it. Give it a bit of context. We can give it examples. We can experiment. If it's not the right answer, ask it again. Or maybe ask another AI model. Go from ChatGPT to Gemini AI or whatever and see what you get there and compare the output. There's other techniques. We'll talk about them as we go through. So we've got prompts. Now, whether they're good or not, it kind of depends on the use case and what we're trying to get out of it. Tell me everything about climate change. That's a little vague. Now, as a kind of a Google search, maybe that would be half decent, but maybe to prompt AI exactly. And I guess there'll be a bit of bias for certain data sets, maybe, depending on where in the world you ask that question. Don't know. But what level? How technical? How detailed? How much output do you actually want? From what perspective? We can make that better, definitely. A little bit more precise. Here's a prompt. Write a 3-page email. So we know how big, we know the format, an email. We know who to, residents, about a new recycling program. Recycling what? Maybe a bit more details needed there. Focus on its benefits and how to participate. Kind of get it. So, not a bad prompt, but we might want to tweak that slightly. That maybe, leaves a little bit to be desired. I mean, it's great for, again, a search engine query, but maybe not for AI. At what level? How much detail do you want? The output we actually want? There's a little bit more precise. Okay, whether it's a good prompt or not, I'm not sure. Act as a city planner, so we know kind of the yeah, context and everything. Suggest 5 innovative ways, so we know kind of the output. Yeah, public transport in a mid-sized Australian city with a focus on sustainability. Yeah, not bad. Yeah, I'm sure it can be improved still. A good starting point. And there's a little example that we can do is we can upload content, examples, yeah, or we can summarize content. Yeah, and this is what my kind of wife uses a lot. She's a primary school teacher. Her Sundays were spent doing a lot of prep work for the following week. And she'd have a lot of the content, but it'd be in the wrong format. So we'd spend most of the time just doing very boring work of making it in the right format. They use a lot of PowerPoint to do their classes with. And because she's a teacher, she gets, shouldn't really say on an AWS one, but you get Copilot with Microsoft 365. And I said, well, you can use it to change the format for you. You can use AI. So with a little bit of help, she's really into it now, and it's cut down her prep time no end. She's got loads of marking and reports and all that sort of thing. But for generating the content, I mean, it's probably the same in New Zealand. The teachers have a curriculum they've got to follow, and they have a few resources where they can grab content, but they've got to prepare all the content themselves. Yeah, and it's time consuming. But she can get AI to do most of the work for her now. And also then from that content, she can create quizzes and things like that as well. So because she can upload the content and summarize it and yeah, ask for quizzes. So it's a lot easier for her, and yeah, she's loving it. Yeah, go for it. But she's making, you know, that she's working smarter, not harder for actually doing it. So uploading content, yeah, is a good one. So what you've got in a prompt is there's different elements that you can include when you ask these questions. Yeah. And some of the basic stuff is obviously we got to know why we're asking the question. So then we can manipulate the actual AI model to get the answer we want. So here we've got an objective. We need to design some feedback survey. Yeah. On what? I don't know, but we obviously supply all that. So we need to give it some instructions. Yeah. We need, in this case, to supply some questions for that survey. And we can tell it that the survey is about public transport. Yeah. So far, so good. We can then tell it to act as a certain role or persona. I'm not sure about a training expert, but maybe a city planner or whatever it is. Council's looking to improve the public transport operations, so we give it some context. Yeah. Then we can place some constraints on the output, the size of the output. In this case, we want 10 questions. Yeah. And we want it to avoid technical jargon. So make it available for public consumption, really. We can give some examples. Examples are a really good one because you've got something you want already. This is the format we want. So trying to explain that might be tricky, but if you just upload it and say, build something similar to this, yeah, it's going to be a lot easier to explain. And it can be a single example, or you can add what they call a few shot, multiple examples in there. You can tell it the tone, humorous, professional, friendly, whatever it is in there as well. And you can get it to show the steps, do it step by step, show your workings and that sort of thing, if you like. If you do a maths exam, well, back in the day when I did a maths exam, it's now math, isn't it? They've dropped the S, but anyway, you got points for the answer, but points for the workings as well, for the step. And that might explain how the model actually works as well. So you get more of an insight of how it's used the data it's actually been trained with. And we have a bit more, if you like, guarantee that the answer you get is kind of genuine and correct because it's almost like showing its workings. And what format do we want that answer in? Well, in this case, we want it in a series of questions in a bulleted list. Now, we don't have to include all those different elements. And sometimes it's easier to tell it what you don't want than what you do want to actually do it. But we can obviously fine tune the type of question we ask, the prompt we ask, based on that kind of idea. So we can start off with certain prompts, and then if we don't get quite the answer we want, we can fine tune them. But if you did these questions in different models, you're going to get different answers because they'd be trained by different sets of data. And that's why when we looked at Bedrock, we got 160 different foundation models available because they've all been trained on different data sets for different use cases. Some of them are good at working with images. Some of them are for words, of course, and language. Some of them are English. Some of them are going to be in another language that they're good at as well. So there's all kinds of reasons why we use the different models for supplying an answer. What are the benefits of using AI in everyday life? That's a reasonable prompt. Again, you might want to specify the format, the level of detail you actually want, technical terms and all that sort of thing in there as well. So we can improve on it. Explain the concept of climate change to a 10-year-old. So we know the level to pitch it, but how much, what format, again, we can include in there and actually improve it. But a lot of time, maybe it's trial and error. Maybe you ask the question, see what the output is. And if it's not what you need, then you'd ask it to reformat that information. Generate 3 creative ideas for a local community event. To do what? To raise money? To get everybody together? I don't know. Again, we could fine-tune that one much better as well, but it's asking those right questions in the first time. Remembering how AI works is a good one, and how it's been trained on these different data sets and how it can understand language. It's all about statistics and probabilities. What the next word is going to be is all done by maths, and it's got those relationships that have been trained into the actual model. We've got different models that have different data sets that have been trained with, and they can work with different size answers. We've got that slider for changing the number of tokens that it actually generates. If you're not sure about the responses you're getting, you can kind of try and validate them. We can force it to reason, give you multiple answers, and then you pick the best one. We've got different techniques to try and improve the output from the AI model. Make it analyze before answering. There we go. Break that information down. Pump the answer back in itself and ask whether that's a good answer. Get it to self-critique. Or put it into another model and see if that's a good answer as well. Rather than get it to check itself, get another model to check it. Try and get different answers from different perspectives and then pick the best one from that. So you can ask the question multiple times, and because we're looking at generative AI, each time you're going to get a different answer, a different format. And that's something I found when I started off by saying, give me an example of AI that's going to impress people. Every time you do it, you get a different solution. Where to from here? Things we need to be kind of aware of, I suppose. The future. Who knows what the future is going to give us, but we've got again an idea that things are going to change. They always change. They're just changing a lot quicker nowadays. The only constant is change. We got some stats here. They apply to Australia, but Digital Nation have done a bit of research and realized there's going to be jobs created. We're probably going to lose a few jobs as well, but that's always happened. When the cloud came out, everyone was a bit concerned that we'd need less people in IT. We're not managing infrastructure, hardware any longer. But what has happened is we seem to be managing a lot more data. And there's a lot more job roles now to deal with data and governance and compliance of that data. And also things like cybersecurity as well. So since the cloud's come along, there's far more people in IT than there ever was. But they've pivoted, they've moved from one particular area of it to another. Certainly we don't need so much hardware and managing of that hardware now. So things will change. I'm not sure about those numbers, but something's going to happen. It's going to affect pretty much everybody in the workforce. I'm not sure just 50%, but maybe even more than that. There won't be too many jobs that aren't affected by AI or are being affected already for it. Again, this is Australia, but you can imagine that's going to be pretty much worldwide on that. So we need to know a little bit about AI. And that's why you're seeing job adverts out there that are asking for that skill set. And maybe that's why we should be doing the Cloud Up course and getting a certification so we can quantify that and put it on a resume and do. But that's why staff should also be trained. And even that's what's happening even at school level in China. Now, we're having a lot of organizations that are just blocking it completely and you can't use AI. which is kind of weird. Yeah, I mean, I remember back in my school days, when I was doing maths, we had logarithm books, and you're allowed to take the logarithm book inside the exam. Before that, you had slide rules, and you had to use a slide rule to calculate things. But then technology moves on, and we have different options. Yeah, after that, we had scientific calculators, so you don't need your logbook. I did have it actually still. I don't know if I've still got it around the place or not. Might be somewhere behind me in my bookcase. But yeah, now you'll have a little app, of course, and you pump something in an app and you get the answer that way. So technology moves on, and we've got to use these new tools that we've actually got. And AI is just really a tool. Yeah. Maybe for good, maybe for bad, but it's a tool. Yeah. Looking at the positives, it should be more inclusive for certain parts of the population that, because of the way technology works, well, maybe couldn't utilize it. But now we've got things like voice to text and text to voice and everything. So that's going to open up certain jobs maybe and certain communication skills to other people. We've got the automatic subtitles and that sort of thing. We've got a lot of medical research that's going on that can utilize all this ability to learn and come up with different solutions. Yeah, we link that with the cloud, of course, and give us the ability to store vast amounts of data and analyze it very, very quickly. I've got to have some bits cut out of my face next week, sun damage and what have you. I went to have a skin check about a month ago, and it's one doctor. And just looking at my face, and he's picked on one area, which I didn't realize was dodgy. I was thinking it was a different area. But you're relying on his skill set. You're relying on his expertise, what he's seen already, or what he's been trained on through books and what have you. If that scan was done through AI, AI would have all this test data and experience that it can draw on and probably find and do a better job of pinpointing the sort of areas that may need further investigation than one single doctor. Yeah. I mean, he picked out a few areas and then we got a biopsy done on those areas, and just one of them is potentially an issue. But in a medical field, yeah, we've got all that data that we can actually pull on, not just the experiences of one person, maybe. There is going to be lots of change and disruption with all this, of course, some for good, some for bad. We're seeing some bad stuff already, of course, out there. Yeah, it's hard to now detect what's genuine and what's been made by AI. And we're getting all those, the fake news stuff and everything as well. There's a nice quote. I don't know where that quote came from, but yeah, again, it's from AWS and their slides. But AI won't replace you, but the person using AI will. Yeah, we still need people. There'll be certain jobs that AI isn't going to remove, of course. Electricians, plumbers, that sort of thing. AI will help them, no doubt, but not completely replace them, not yet anyway. But who knows? Yeah. Some jobs are going to be affected more than others. We've got technology happening all the time. Even though these are all different types of technology, they've all kind of got some link with AI and affecting them. So all the different controls we've got now in new cars, we've got electric cars. My wife, being a primary school teacher, can salary sacrifice. So we've got an electric car on lease, saving us a fortune. Yeah, I'm not sure how green it is. It's still lots of metal and plastic, and there's a big battery that something's got to happen to in about 10 years' time that I'm not sure how it can be recycled. But I guess as it drives, it's not throwing nasty things out. But if I don't charge it on the solar, it's going to be charged from electricity from a power station that burns coal. So there's still issues with it. I had someone say it's new technology the other day, and it's not that new. I remember as a kid, we used to have electric cars. We had electric milk floats delivering the milk on the doorstep. I mean, that's going lead batteries at the time and everything, but that's well old. So technology is not that old. There's some good bits. Yeah, we don't need so many services with it because there's only about 200 moving parts, whereas in a traditional car, there's about 2,000. So then you think there's a knock-on effect for things like garages and mechanics. Their skill sets need to be changed. They need to be working with electrics a lot more than traditional mechanical bits. Yeah. Fuel stations, petrol stations. Yeah, we won't need so many of those because there'll be less cars using petrol. There is issues. Is it available to everybody? Well, if you live in an apartment, it's going to be very hard to charge your car, your vehicle. Yeah. In the UK, you've got lots of high density housing, back-to-back housing, the Victorian terraced house type thing. So they kind of park on the street, but then you won't be able to put a power cable to your house and leave the lead over the footpath because people will trip over it and sue you. So will they be able to use electric cars? There's issues now with governments getting funding. They've suddenly realized revenues dropped because people aren't buying petrol. And petrol, big part of the price of the fuel, is a tax to the government. So now they've got to think about a new way of taxing car ownership. Is it on a per kilometre you drive kind of basis? But we've had the same issue with things like solar panels. Yeah, originally the power grid was designed to put power one way and not bring it back the other. So all these companies have had to invest in their actual power grid while people are using less and less electricity from them. So revenues are going, but costs are going up. Then we've got batteries added to it as well. But if you rent, you can't utilize that kind of technology. You're not allowed to put solar panels on and everything on other people's houses. And if you're in an apartment, where you're going to put the solar panels? So there's kind of issues there as well. We've got self-drive vehicles, autonomous vehicles. Again, sitting with me dad a few months back when I was in the UK, he sort of mentioned that, oh, I'll never see self-drive vehicles before I die, sort of thing. He's 89, so he ain't got too many years left in him. But I did say, actually, Dad, they're there now. You can use that functionality in a Tesla. I said, but also in California, they've got self-drive taxis. Yeah, they're converted Jaguars. The steering wheel still goes round, but no one's sitting in the driving seat. And they've got enough data now to prove that they're far safer than traditional people-driven vehicles, which then leads on to, you won't need train drivers, you won't need taxi drivers, you won't need truck drivers eventually, but that might take a while. And there's an awful lot of people employed in that type of area. Yeah, but then you won't need car parks, because if you go shopping or you go to the airport or something, you can just tell the car to drive home and it will be waiting for you at home. The government's going to lose out again with speed cameras and things, because these cars will be that controlled, you won't be able to speed. They'll be able to talk to each other, so maybe Perth drivers can merge eventually and you won't need traffic lights or anything. So the whole design is going to change, maybe, of the road structure. Maybe we won't own cars. You just call one up when you need one, because they can live somewhere, and then you just grab one when you need it and return it when you've finished. I'm looking forward to be able to go to the pub, have a beer, and still drive home, because the thing will drive itself. At the moment, if I go to the pub, I tend to have to go on a push bike, but there's some weird rules about driving or cycling drunk. You might lose your car license anyway, apparently. And we got robotics. We've had robotics for years. We've got assembly lines and all that sort of thing, but now you're seeing it to protect people in firefighting and things like that. They send in robots rather than people, and the armed forces are doing that sort of thing as well for mine clearance and that sort of stuff. I went to Melbourne the other week. I mentioned that and did me expenses, but I went to a restaurant with my daughter who's over there, and she took me to one that I was served by a robot. This little thing came along with a tray. Yeah, so you don't need waiting staff now. Someone's got to put the food on the tray, I suppose, in the first place, and actually do that. But it's a bit of a gimmick, but it was different. Yeah, we've got drones and things, and the technology there. I'm not sure about delivery with drones, because again, we've got issues with apartments and all that sort of thing, and high density housing. But you're seeing it, with sports things, with the individual shots above the grounds and golf courses and all that sort of thing. YouTube content, it's all over it, of course. So whereas maybe it would have been done through a sort of helicopter doing it, and pilots and all that, now you can just send up a little drone up there to do it. We're also seeing it in wars now as well, of course. So for bad as well as for good, maybe, on that one. We've got chat bots, we've had them for years, but they're getting better and better. Yeah, some of the newer ones, it's very hard to tell that you're actually talking to a person. We have that functionality in ChatGPT where you can start talking to it. And that then leads on to, we don't need actors. We don't need voiceover people. Yeah? We won't need developers writing code. We won't need trainers delivering sessions like this. Ooh, things are going to change. And of course, we've got generative AI, which sits on top of all this and generates new content. So how's that going to affect artists and musicians? You know, we don't need translators. You know, we don't need, you know, so many news reporters and things like that, and journalists. It goes on and on for it. So just a food for thought, I suppose, that one. We've got to remember how AI actually works. It's all about statistics and mathematics, predicting the next word in there. Yeah, not every single option is programmed in the code. They are trained on certain data. How good they are depends on how well they've been trained in the first place. If you don't like what you're seeing, you can build your own models. We've got tools inside AWS to do it. Yeah. Answers blend training data based on context. We can supplement these pre-configured models with our own data sets, knowledge bases, augment them. Retrieval augmented generation, RAG is the phrase they actually use. They're not always 100% correct. They make things up. We've seen that with some examples that I've gone through. They hallucinate. Yeah. The information may be slightly biased to one part of the population than another. And we've got to be careful of that. We've got to make sure they're fair. Yeah. If we use AI to generate other AI, is each generation getting better or is it getting worse? Yeah. Again, we need to monitor it to check that out. Yeah. Interesting. So it should improve people's kind of workloads. We should be able to do things far more efficiently. Yeah. Automate more, make it more consistent. Yeah. We can try very quickly new issues like build a soft drink can, with a design on it very, very quickly. So again, we can be inventive. I can't even say it. Improve decision making. One area that we haven't really touched on of AI is kind of predicting the future based on certain previous information. So we can train it on previous data, and then it can use that. It can kind of predict the trends for the future. House prices, stocks, that type of thing. Interest rates, all that sort of stuff. Weather patterns. We have got to worry about the ethics and the security of the data and all that sort of thing. And there is a big issue now with a lot of it being held offshore. And a lot of the companies or countries are now thinking maybe they need to get into this themselves and make sure they're supporting solutions that are actually onshore that they manage rather than relying on other countries for this AI. So there is issues and challenges coming up there. People, we've got to be open-minded. We've got to be able to use it, but no, it's a tool and it's not always 100% correct. We can augment what humans can do with it, but not completely replace it, maybe. There is going to be a change in job market, of course, to actually do it. And a few little, again, food for thought. How many companies are going to experience a Kodak moment? Now, if you're not sure, Kodak were into photography in a big way, but they missed out on digital photography. They weren't there at the start. And we've kind of seen the same with some of the traditional car companies not getting into electric cars. And now they're being sort of surpassed by other companies, new starts that have kind of gone into that technology. Sometimes these companies are so large, it's very hard and it takes a while for them to pivot into a different area. Is everyone going to be fit for the journey for AI and understand AI? Well, there'll be certain job roles that will disappear completely, and they might be more low-skilled job roles. So what do we do with those lower-skilled people? And again, there's a lot of discussion on this, and there was an article a couple of weeks ago in the ABC, or on the ABC here, talking about the fact AI might take away a lot of these jobs. So there might be a portion of the population that just can't find work. So maybe we're looking at universal basic income again, and they kind of hark back to in COVID times where there was a kind of cover for people that couldn't work during the COVID period. I'm not sure if I've got that one on the GitHub page, so we'll paste that one in there. So we need to embrace new technology. I kind of think everyone's probably aware about that one nowadays, but it just changes so quick. That's all. You need to maybe experiment with AI. Make sure that you know what it can actually do and see if it would be useful for your organization or for even just for your personal use as well. So try it, pilot it, have some solutions. Look at some of the tools we've looked at, Party Rock and things like that, and see if you can actually weave a bit of AI into your daily routines. Try it in a non-critical area, of course, learn the skills, and then you can think about putting it into different areas. We should have a culture of continuous learning, of course. Invest in training. There we go. That leads us back to this one again. Identifying new and critical skills. We need to know how to use AI and the safeguards that we need to put on it as well, of course, with governance and compliance and the idea that it can hallucinate and make up sort of rubbish, if you like. If you are going to incorporate into an organization, it's got to go across your different departments. We need to be, obviously, it's an IT area. You need to look at risk management. We look at HR and everything as well. And finance and accountants will come into it and everything as well, of course. Yeah. Poor prompts deliver poor output. You've got to ask the right questions to get the right answers. So experiment. Yeah. What are the key elements of the prompt and prompt engineering that you can supply to get a better answer? And a lot of it may be examples, but you can work backwards. You can tell it what you don't want. That might be a useful technique as well. Most of the AI using is chat-based, but we can communicate via voice as well, of course, and have a conversation that way. But the idea being is if it gets something wrong, you can tell it and it should correct it. It didn't quite work for me until I hit my limit, but maybe if I kept going, it would have corrected the mistakes that I found in those diagrams earlier. AI can assist with tasks like, yes, summarization. We're doing a summary of this session now, as well as recording it, of course. We can brainstorm. We can get things up and running and multiple ideas so we can pick the best. Yeah, we can analyze data, of course, as well. If you ask AI to provide references, you can kind of check itself. Yeah, not just the answer, but how did it get the answer? Yeah, where did it get that information from? Reasoning models will provide their train of thought. Well, that's kind of the same idea, really. Yeah, break things into manageable chunks. Yeah, explain it. They are people pleasers. AI will generate an answer, whether it's correct or not. That idea of hallucinations. So we do need to check it and validate that answer, of course. And you can validate it by feeding it back into itself or into a different model. Optimize your prompt. Yeah, if it doesn't work the first time, modify it, change it based on the output, of course. But always check. Yeah, it's not always 100% correct. Right. If that was interesting, especially the AI bit, there is that 6-week course, the Cloud Up course. We run them pretty much, every few months anyway. So if you can't get into the next one, there'll be one coming up sometime after that one finishes as well. But with the next ones, we're getting this kind of sponsorship from AWS, and we've got these discounted prices. So for $49, I think there's still a few of those places available. This is the last session of 9 that we've actually been doing in this batch. And if you sign up, you get 6 weeks online content with the different modules that make up the course, with Q&As and videos and that sort of thing in there, and a little person doing a bit of talking and that sort of thing. But you also get exam prep, and you also get a weekly session with a trainer, a live person, where you can ask questions. If you can't make that, that is recorded, so you can always view that online as well. You get your voucher for your exam. You've got to sit the exam yourself. No guarantees you'll pass it, of course, but we'll try and point you in the right direction for that one. The first 200 that do pass it will also get that t-shirt. Yeah. Now, there is that link there, but I think James has already been putting the link in chat as we've gone along. If you've got a mobile phone, I'm sure you can click on the QR code that's displayed at the moment as well. That's just some same information, but in a slightly different format from our marketing people. But the aim of the goal is to pass an exam at the end of it. So you can add that to your resume and quantify that you know a little bit about AI as a starting point. It's a foundation exam. There's a whole series of exams within AWS that you can actually do. There is prep guides for it. There's certain information that we know you're going to get asked questions on and the type of the questions, and we cover that when we actually do it. When I click on the link, and I'll copy that link into the chat, you can see what you're required to actually do that exam. I think it's 90 questions, 65 minutes, but if I scroll down, there we go. Yep, 90 questions, 65 minutes. It would normally be $100 US, so getting it for 49 and all the training is a really good deal. And they tell you the type of questions you get. They give you an exam guide. So there's a huge database of questions, and you just get a subset based on certain categories or domains, as they call them. So we're not exactly sure what questions you're going to get, but we know roughly the style of them. And if you scroll down, they even give you the type of the content that you need to know. So you can use this as a bit of a checklist, and then yeah, you can hopefully go and sit the exam and pass the exam at the end of it. That is all the content covered. So we started off, I just mentioned a bit about the cloud and AWS opening up their region in New Zealand. What services are offered by AWS, and some of them are these like black box services where we just basically use them. So we connect to them through API calls and that, and we've got ones to play around with text and images and that. We looked at some case studies where different companies have actually used that technology as a live solution. We also mentioned about Bedrock and SageMaker. So if we want to take it to the next level and build our own solutions, either within Bedrock from these foundation models and tweak how the parameters work, augment them with our own data sets, put our own controls on them, guardrails as well. Within SageMaker, we can actually prepare the data to train the model in the first place, to test it, to evaluate it, and then obviously produce it and make it available, look at all the compliance issues and everything with it, continually monitor it as well. So the whole life cycle of the product with SageMaker, or SageMaker AI as it's now being called. And then we delved deeper into AI and looked at large language models, how they work, how we work with images, and also gone into a bit of prompt engineering by formatting the right questions to get the right answers, and some gotchas with the idea that it does make mistakes. We saw that throughout with the little demos and that, with the idea of hallucinations and making sure that they're fair and they're not biased to one part of the population or another. Now, if you do the training course, they go a lot deeper into all those different areas, of course, and a bit of playing with the product as well. Hopefully you've been asking questions. I've not monitored the chat myself, but James has been there. So answering those questions. I'm not sure how many we had this session. It seems to vary across the different sessions. Sometimes we get lots, sometimes not so many. We're about coming to an end. So if you have got any questions that are outstanding, pop them in now and we'll answer them before we close the meeting. But if you haven't, thank you very much for listening. You've survived the 3 hours. You've done well. It's just popping up to 10 o'clock here in WA. So time for a coffee and a quick break. But I guess it's much later in the day for you in New Zealand. But thank you very much, and hope you've got something out of that. And good luck with your AI journey.
And thank you, Adrian, for your time this afternoon, and thank everyone else for their time this afternoon. Hopefully everyone has a great weekend. To answer a question that I've seen pop up a couple times, this has been recorded. Don't know exactly when that's going to get popped up, get processed and put out there as soon as possible. But again, thank you all, everyone, and have a great weekend.
Oh, yeah, it's Friday. Way. Cool.